Uh, right. Right. Okay. Right. Okay. Now we'll start the story. Right. Okay. Right. Plan is now, especially this is for 2027 students, but that does not mean that this is not belongs to 2026 students, right? Everyone can get a benefit from this session, right? Mostly students who are going for the first term test based on to give a small support from my end. So thought of doing this session, right? My target is to discuss I have planned to discuss around six task essay questions today, right? And if you have enough time, especially those task essay questions are from measuring instrument section, and if we have enough time, then what will we do? We'll go to the force equilibrium stories and we'll cover some force equilibrium essay questions as well, right? Overall, today plan is we are doing vernier caliper, micrometer, and sperometer stock essay questions from past papers as well as I will give some model papers. Also, I will share the group. The next story is if we have enough time, then we'll do some questions in force equilibrium also. That is the overall idea, right? That is the idea, right? Okay, we can start now. Now I shared the past papers in the group. We'll start from 2024 A level. That statistic came from micrometer gauge. We'll start from 2024 A level. That statistic came from micrometer story. Just quickly open the story and refer it. That story. That story. That story. Refer it. Refer it. Right. That story. Refer it soon. Okay. Right. That question. That story. That story. Now, 2024 A level, that statistic question is from micrometers story. Now, stay focused. I will try my maximum to explain, not going in deep and I'm not explaining theories, but something to be memorized. I will give a small brief and I'm quickly cover these statistic questions, right? Stay focused, right? Stay focused. The time that you spend, I think time is very precious, right? Give a value, add a value for the time that you spend. That is the important story, right? Okay. The first story, and now 2024 A level question. 2024 A level question. Right. 2024 A level stock essay question. Now that is from structure essay. That is from micrometer. That is from micrometer story. Micrometer story. Micrometer. Okay. Right. Read the question. Read the question. Now the story says that you are asked to determine the density of the material of a thin uniform wire of length about 15 centimeter and mass about 200 milligram. Density of a wire length is about 15 centimeter, mass about 200 milligram. You are provided with the micrometer screw gauge shown in the figure to measure the diameter of the wire, right? So we'll try to understand what is the connection between diameter, length, mass and density. We'll talk that story later. Simply name the parts of the micrometer screw gauge marked as AB, not the two scales, marked as A, B and C. A, B and C, right? If I roughly draw that ABC parts, simple story. Now, simple A, micrometer, this part is, if you can remember, the area, if the section where the main scale is engraved is what we called as sleeve, right? The section, the component where main scale is engraved is we called as sleeve. That is what they mentioned as capital A, capital E, right? Then what is B? B means we know that B should be thimble. C must be the thimble head. That's what we know. That's what we know, right? Okay, right. This is capital B. And then we can see that small thimble head, right? So we want to name what is ABC. A is sleeve, right? The main scale is engraved sleeve. And the capital B is the thimble. Where we rotate, why do we use thimble? To rotate to move the spindle back and forth motion. By rotating the thimble only, we are moving the spindle back and forth, right? Capital B is the thimble. Capital C must be thimble head. If not, we call it as ratchet head. Thimble head. Simple. So A is sleeve. Capital B must be thimble. And capital C must be a ratchet. If not, we can call it as thimble head also. Thimble head. Thimble head. Right, simply part. Right. Now you want to understand that the circular scale is engraved on the thimble. That story, remember, right? Simple story finished. Then they ask me what? Simple B part. Simple B, they are saying that the main scale of the micrometer screw gauge is, the main scale of the micrometer screw gauge is made by dividing 1 millimeter into 2. The main scale of micrometer screw is, the main scale of micrometer screw gauge is made by dividing 1 millimeter into 2. The circular scale has 50 equal divisions. One complete turn of capital B will either increase or decrease the distance between the anvil and the spindle by a value which is equal to 1 division on the main scale. What is the pitch of the micrometer screw gauge in millimeter? What is the pitch of the micrometer screw gauge in millimeter? If you can remember, I explained in the theory classes. Generally remember simple B. Simple B, Roman number 1. Okay? Right? This story. Now I told you that micrometers, they are using that screw principle. A screw principle. I told you that when the screw is rotating one complete rotation, the distance traveled by the screw tip is equal to the pitch. Rough small story, a small story. Right? So we all know that when the screw is rotated by one rotation, one turn, the distance traveled by the screw tip is we called as, if you can remember, that is the pitch, simple P. Right? Okay. Then I told you that pitch is what is pitch? Pitch means the adjacent distance between two threads in the screw. Even in the micrometers also I told you that If you remove the micrometer components, you can clearly see a screw, right? Basically, screw is moving back and forth motion. I told you that in the classes, right? When you rotate the screw, if not in the micrometer, when you rotate the thimble by one rotation, the spindle is moving back and forth, right? When the thimble is rotating by one rotation, the distance traveled by the spindle back or forth is equal to the pitch. Also, I told you that if you can remember, they manufactured the pitch always equal to the smallest division in the main scale. Right? Remember, pitch is equal to the story. Pitch is equal to the smallest division. Smallest division in the main scale. Smallest division in main scale. Right? In main scale. Main scale. Now, in the question, they mentioned that in the main scale, that 1 millimeter division is further divided into 2. Right, then what should be the minimum division in the main scale? 1 millimeter over 2. Then you know that how should the main scale looks like. In that case, this is the index line. This is the 0 division of the main scale. This division belongs to 1 millimeter. This division belongs to 2 millimeter. In the question, they mentioned that the 1 millimeter division is also further divided by 2. That means we can see divisions in the both sides of this index. We can see the divisions from both sides from the reference line, if not index line. This division belongs to what? 0.5 millimeter. This division belongs to 0.5 millimeter. This division is 1 millimeter. This division is 1.5 millimeter, 2 millimeter, right? Remember, summary is simple. Summary is very simple. When the thimble rotates one rotation, your spindle moves a distance equal to pitch. That pitch is always equal, remember, in micrometers, pitch is equal to the smallest division in the main scale. In the given question, tell me what is the smallest division in the main scale? That is 0.5 millimeter. The given question, smallest division in the main scale is how much? That is 0.5 millimeter. Then remember, pitch must be equal to the smallest division in the main scale. That means 0.5 millimeter. Right? Very simple story. So therefore, simple B. Simple B, Roman number 1. What is the pitch of the micrometer screw gauge in millimeter? 0.5 millimeter. Right? Simple, what is the answer? Simple B must be, Roman number 1 must be, right? Pitch is equal to how much? 0.5 millimeter. Roman number 2 they are asking, what is the least count of the micrometer screw gauge in millimeter? What is the least count of the micrometer screw gauge in millimeter? Least count equation we can remember. Least count for a micrometer and spirometer. The least count equation is, remember, pitch over number of divisions in the circular scale. Right? The least count is, remember the equation, least count LC is equal to pitch over number of divisions in the circular scale. We found pitch is 0.5 millimeter. If you know the number of divisions in the circular scale, then we can easily find the least count. That story. The least count is pitch is 0.5 millimeter. When you consider this is the main scale. When you consider the circular scale, right? They mention clearly, circular scale is divided into 50 divisions. There are 50 divisions circular scale. What is your simple name? Simple and mass 50. Number of divisions circular scale is 15. They have given like that. They have given the question. They mentioned the main scale of the micrometer screw gauge is made by dividing 1 millimeter into 2. That means smallest division of the main scale is 0.5 millimeter. The circular scale has 50 equal divisions. Circular scale has 50 equal divisions. Number of divisions circular scale is how much? 50. Therefore, least count is 0.5 millimeter over 50. Therefore, LC is 0.5 0.01 millimeter. Least count is 0.01 millimeter. If you have any doubts to be clarified, you can use that chat and you can ask your doubts, right? We can clarify it, we can smoothly, calmly, we can do this story, right? Next story, next idea done. Then simple C part, simple C. Figure 2 shows the position of the circular scale when the anvil and the spindle touch each other. Determine the value of the zero error of the micrometer screw gauge in millimeter. So we are talking about two types of zero errors. In micrometers, one is positive zero error, other one is negative zero error. A small brief. So we all know that explained already, positive zero error. That is what? How do we know that positive zero error means what? Right, this is the main scale reference line, if not index line. Main scale index line. This is the circular scale H. Okay. If your micrometer is accurate, when you bring anvil and spindle, if you just touch anvil and spindle, if not when you bring anvil and spindle in contact with each other, if your micrometer is accurate, the zero division in the circular scale should exactly coincide with the reference line, if not the index line in the main scale. Right? If there is no zero error, you should understand zero division in the circular scale should exactly coincide with the reference line. Right? But most of our lab equipments, we know that because of the usage, definitely there are zero errors. Sometimes there can be many, there can be corrosion and there can be positive zero error. Some micrometers can undergo kind of worn out and there can be some negative zero error. Right? Zero in the circular scale is exactly coinciding with the reference line means no zero error. This is what we call as reference line, if not index line. Reference line, if not index line. Right? How do we identify whether there is a positive zero error? I told you that if the micrometer undergoes positive zero error, zero division in the circular scale must be exactly bottom, below. If the micrometer has positive zero error, zero division in the circular scale should be below from the reference line. Right? The next thing is circular scale edge is right side from the zero division in the main scale. Right? There are two conditions occurring simultaneously. If your micrometer undergoes positive zero error, first story is what? Zero division in the circular scale is below the reference line. Second condition is circular scale edge is right side from the zero division in the main scale. That story. Right? Negative zero error means we all know that. Negative zero error means what is the condition? There are two conditions happen simultaneously. The first condition, if the micrometer undergoes negative zero error, zero division in the circular scale is above the reference line. And also you are not able to see the zero division in the main scale because it is completely covered by the circular scale. Therefore, in case if your micrometer undergoes negative zero error, you are not able to see the zero division in the main scale. That story we know. And now from the story we can understand, this question we can understand. Now we see, now look at the zero division. Simple C figure 2 shows position of the circular scale when the anvil and the spindle touch each other. Determine the value of the zero error of the micrometer screw gauge in millimeter. Now we can clearly see that in that story, zero division in the circular scale is above the reference line. So therefore that is belongs to negative zero error. That is belongs to negative zero error. What is the equation? To find the zero error, if it is positive, zero error equals what? Zero error equals, we know that the division coinciding the reference line. Right? The division circular scale coinciding reference line into least count. Right? If your micrometer undergoes negative zero error, what is the equation to find the zero error? Zero error. Let's say this is the division. Q division is coinciding with the reference line. The equation to find zero error is what? Zero error equals negative zero error equals number of divisions in the circular scale minus the division in the circular scale coinciding with the reference line into least count. Into least count. Story. Least count. The equations. The equations. The story we know. The story we know. Right. Then simple C story, isn't it? Simple C story. Reference line is given. Circularly zero division is above. We can clearly see that zero division in the circular scale is above the reference line, negative zero error. Find the division. The division coinciding the reference line. It is 45, 46, 47, 48. 48 division in the circular scale is coinciding with the reference line. 48 division. If you clearly see that 48th division coinciding with the reference line. And also how many number of circle divisions in the main scale? Sorry, circular scale. How many number of divisions in the circular scale? 50. Simple N is 50. Q is 48. If you want to find the zero error, negative zero error, what is the answer? Zero error equals what? Zero error equals N minus Q into least count. N minus Q into least count. Number of divisions in the circular scale, that is 50, minus the division in the circular scale coinciding the reference line, 48. Least count, just now I found the least count is how much? 0.01 millimeter. Least count is 0.01 millimeter. What is the answer? Zero error going to be how much? Zero error going to be 50 minus 48 is 2. 2 into 0.01 means 0.02 millimeter. 0.02 millimeter is your answer. That story. That story. Right? Next idea. The next story is also done. Then simple D part. After determining the... Okay. Now simple C, this is the figure 2 shows the position of the circular scale when anvil and spindle touch each other. Determine the value of the zero error of the micrometer screw gauge in millimeter. That is okay. That is okay. Next one, simple D. After determining the zero error, state how the micrometer screw gauge is used to measure the diameter of the wire. After determining the zero error, state how the micrometer screw gauge is used to determine the diameter of the wire. Right, that story simple D. Now easy. Simple D part is easy, not difficult. Simple. Simple D story. Simple D. Simple D. Right. Quickly keep on, in case if you could not write anything, just quickly take a moment and quickly write down the stories quickly. Samma will discuss six start to say questions and right, we'll plan to do few more questions. Okay, we'll plan to few more questions. Keep on doing. Keep on doing. Keep on doing. Okay. Keep on doing. Keep on doing. Right. Right. So we want to finish soon this question because we can't take that much of time. Right. We'll finish it soon. Right. Next story. Simple D story. Simple D. Simple D story. Simple D. Right. Simple D, they are saying what? Simple D, after determining the zero error, state how the micrometer screw gauge is used to measure the diameter of the wire. Then what is your first way? How do you measure the diameter of the wire? First, you want to place the wire in between anvil and the spindle, right? So how do you ensure that, right? How do you ensure that anvil and spindle just touching the wire, right? Sometimes we all know that sometimes spindle can overpress the wire and it can deform the wire, right? So therefore, when you're writing the answer for this simple D part, you want to be very careful. First, you want to write down, I think number one, you should write down, I don't write in the board, you should write down a story like this. First story you want to write down. So you want to place the wire in between anvil and spindle. First, we should turn the thimble, right? I told you, right? I told you, till the thimble, now, till the spindle just touch the wire, you should rotate your thimble, right? After spindle almost reach the wire, further you want to use the thimble head, then you should rotate the thimble head till you are hearing the tickling or clicking sound. That's how you ensure the contact of anvil and spindle with the object, with the wire, right? So you want to mention very simple story, right? The very simple story. First, what you want to do? First, right? Somehow we should bring the contact. We should place the wire and we should hold the wire using anvil and spindle, right? So then in that case, you should move the spindle towards the wire, right? In that case, first you want to use your thimble and you should rotate your thimble till the spindle almost reaching the wire. Once it's almost reached the wire, you should use the thimble head and you should rotate the thimble head till spindle just touch the wire, right? After spindle touching the wire, when you further rotating the thimble, what will happen? You are hearing kind of tickling or clicking sound. That is the idea. That is the idea, right? After doing that, the next thing you want to mention is normally we don't obtain one reading, right? Generally, remember, right? When you're measuring the diameter of a wire, we don't obtain one reading. Okay, you should turn the wire and you should obtain the diameter. You should take the measurement from the micrometer for three different positions. Okay, so you are keeping your anvil and spindle in this position and you are measuring the diameter D1. This diameter is D1. And then you are placing your anvil and spindle in this position and you are obtaining again the diameter. At least you should obtain three readings D1, D2, D3, and you want to obtain the mean of those three measurements as the diameter, right? To get a more accurate diameter, we should obtain the mean of them. That story is okay, right? Done. Next story. What is the purpose of having part C in the micrometer screw gauge? I told you, this thimble head protects over pressurizing the object to be measured. If not, it is protecting the deformation of the object to be measured, right? It is the mechanism, right? Okay. Simple E part also done. Simple D story done. Simple E story also discussed. Simple E story also discussed. Done. Simple F. Simple F idea. Simple F. Figure 3 shows the position of the circular scale when the diameter of the one place of the wire is measured using the micrometer screw gauge mentioned in C above. What is the reading of the micrometer screw gauge in millimeter? Right. Quickly now, just tell me everyone, quickly tell me, when you go to the diagram, figure 3, what is the micrometer reading? You should obtain the main scale reading and you must obtain the circular scale reading also. What is the answer? Simple F Roman number 1. Simple F Roman number 1. If I draw the diagram, our main scale, 0 division the main scale, okay, we can barely see that 0.5 millimeter division in the main scale, right? Okay, we can see the 0.5 millimeter division in the main scale. This is belongs to 0.5 millimeter. This division belongs to what? 0.5 millimeter. 0.5 millimeter. Okay, I explain here. Right, 1 millimeter division is divided into 2. Therefore, this division belongs to 0.5 millimeter. So then what is the main scale reading? Main scale reading is 0.5 millimeter. The nearest main scale division to the circular scale edge is 0.5 millimeter. So main scale reading is how much? Main scale reading is how much? 0.5 millimeter. Then how do you obtain the circular scale reading? You should find the division in the circular scale coinciding with the index line. Then we can see that 5, 6, 7, 8. 8th division is coinciding with the reference line. Right? 8th division. The division is 8th one. So your Q is 8. Is 8. The division in the circular scale coinciding with the reference line is what? 8. Your Q is 8. This is your Q. How to find the circular scale reading? Main scale reading is 0.5 millimeter. Directly we can read it from the main scale. But you can't you can obtain the circular scale division coinciding with the index line. But if you want to obtain the circular scale reading, you want to multiply the Q by the least count. Remember, circular scale reading means what? The division in the circular scale coinciding with the reference line into least count. This story put in your mind. This story put in your mind, then circular scale reading. Therefore, circular scale reading is how much? Q is 8, 8 into least count is how much? Least count is 0.01 millimeter. Least count is here we found 0.01 millimeter. Least count 0.01 millimeter. Therefore, circular scale reading is equal to how much? 0.08 millimeter. They are asking the reading obtained from that micrometer. Right, that observed reading. Observed reading is what? Main scale reading plus circular scale reading. Therefore, even though I do these in many steps, by looking at the diagram, you should be able to identify main scale reading is 0.5 millimeter. Right? So then the division of the circular scale coinciding with the reference line is 8. To obtain the circular scale reading, I want to multiply 8 by the least count, then 0.08. Right? Then I want to, in order to obtain the observed reading, I want to add the main scale reading and circular scale reading. Even though I write in some steps and I do, you should be able to get the answer from your mind. Do you understand? You should be able to get the answer from your mind. That is important. For you, for everyone to understand the idea step by step, calmly, slowly I am doing. But when you are doing in the exam, you don't want to follow the steps. Is it difficult? Main scale reading is 0.5 millimeter. Circular scale reading is what? 8 into least count is 0.01. 0.08 millimeter is the circular scale reading. And then 0.5 millimeter plus 0.08 means 0.58. Right? Observed reading is what? Observed reading, main scale reading plus circular scale reading. Therefore, observed reading is what? Main scale reading is 0.5 millimeter, 0.50 millimeter plus circular scale reading is how much? That is how much? That is how much? 0.08 millimeter. Finally, we are getting that 0.58 millimeter as your observed reading. Observed reading, right? Okay. Simply from number 1 they are asking. What is the reading of the micrometer screw gauge in millimeter? 0.58. Done is simple. Number 2. Number 1. Number 2 they are asking. Number 2 they are asking. What is the correct value of the number 2, what is the correct value of the diameter of the wire in millimeter? Actually, we were measuring the diameter of the wire before obtaining the reading. First, we found the zero error. We realized it's a negative zero error. Negative zero error was how much? 0.02 millimeter. Then observed reading is how much? 0.58 millimeter. Alright, then in a micrometers, if it is having a negative zero error and if you want to obtain the correct measurement, the correct diameter of the wire, what we should do? We should add the zero error to the observed reading. We should add the zero error to the observed reading. Remember, if there is a negative zero error, we are adding the zero error to the observed reading to obtain the correct measurement. If there is a positive zero error, we are subtracting the zero error to the observed reading to obtain the correct measurement. Right? Since in this scenario, we have a negative zero error, to obtain the correct measurement equals what? Observed reading plus that negative zero error, that zero error. Then observed reading is 0.5 millimeter, 0.58 millimeter, plus zero error I found that it is 0.02 millimeter. 0.02 millimeter. 0.02 millimeter. Our answer is going to be how much? 0.60 millimeter. That is our correct measurement, if not diameter of the wire. The correct diameter of the wire is how much? 0.60 millimeter. Very simple. The last one story finished. Story finished, the last one. The last one they are saying what? Last one, Roman number 2, calculate the cross-sectional area in millimeters squared of the wire using the value F1 Roman number 1, 2. Take pi as 3. That is easy. That story is easy. That story is easy. This story, listen. This story. Look here. Now, when you consider a wire, you can assume that it's a cylindrical object. A wire, we can assume it as a cylindrical object. Right? It's a wire. Okay? So, when you consider a cross-sectional area of the wire, if you zoom it, the cross-sectional area of a wire is a circular area. It's a circular area. The cross-sectional area of wire is what? A circular area. Circular area. So I want to find the area of this circular cross-section. Right? I found the diameter of this wire. If not diameter of the circular cross-section, I found 0.60 millimeter is the diameter of the circular cross-section. Right? Okay. What is the equation to find the circular area? If you know the diameter. Always we learn that area equals pi r squared equation. R is radius. If you write radius in terms of diameter, radius means diameter over 2. So therefore, area equals how much? Area equals pi. Radius means diameter over 2, d over 2. D over 2 whole squared. Then we know that, remember, cross-sectional area in terms of diameter is, remember, capital A equals pi d squared over 4. Pi d squared over 4. What is the pi value? They are asking us to consider pi as 3. Diameter is 0.6 millimeter. 0.6 squared over 4. Over 4. Right? So when you simplify it, 3 into 0.6 squared is 0.6 into 0.6 over 4 means what? 4 means we can write on 2 into 2. 0.6 over 2 means 0.3. If you divide 0.6 over 2 means 0.3. Then 0.3 into 0.3 into 3. You are getting the answer. 0.6 over 2 is 0.3. 0.6 over 2 is 0.3. So when you multiply, when you get the answer, the cross-sectional area is how much? That is going to be how much? That is equal to how much? 0.27 millimeter squared. Simple. Right, simple story. Next one, simple G. Simple G, what other measurements do you take to determine the density of the material of the wire? Right. So now density means we all know that. Right. Density means we all know that. Give me a second. Right. Okay. Right. Okay. Right in the last story. The last story. What is the other measurements do you what is the other measurements do you take to determine the density of the material of the wire? Just remember now all levels you learn that density means what? Density means we all know that density equals mass over volume. Right? Now if you assume your wire as a cylindrical object, you know cross-sectional area of the wire. You know capital E, cross-sectional area. Okay? Then for a cylindrical object, how do you find the volume of the cylinder? Volume equals what? Cross-sectional area into height. Oliver equation. The volume of a cylinder is equal to what? Cross-sectional area into height. Cross-sectional area into height. Right? Since I know the cross-sectional area, I should know the height. That means its length. So I require height of the wire, if not length of the wire. Right? Then if I know the length of the wire, I know the cross-sectional area of the wire also. Therefore, I know the volume. But to find density, I should know the mass of the wire. In that question, simple G Roman number 1, they are asking what other measurements do you take to determine the density of the material of the wire? Means we know the cross-sectional area, therefore we require the length of the wire, then only we can find the volume. And since density means mass over volume, we should know the mass of the wire, right? Mass and length of the wire, those are the other two measurements, right? Then Roman number 2, next story. Name the most appropriate measuring instrument need to be obtained. Name the most appropriate measuring instruments need to be obtained, the measurements mentioned in G Roman number 1 above. If we want to measure the length, we can use meter ruler, right? Then if you want to obtain the mass, you can use electronic balance, if not triple beam, to measure the mass. Simple. The last section. The last story, the last section is what? Figure 4 shows an electronic micrometer screw gauge used in industrial applications. What is the least count of the gauge in millimeter? Now when you go to that screen, you can see that it is measuring 6.467 millimeter. Right? Simple H story. Simple H. The measurement is how much? 6.467 millimeter. 6.467 millimeter. That means this device, this electronic micrometer can measure measurements up to 0.001 millimeter accuracy. Correct? See, 6.467. This electronic micrometer can measure the measurements up to 0.001 millimeter accuracy. The least count is 0.001 millimeter. Finished. That story finished. Just put some replies in the chat. If all clear, all good, just put a reply. All clear, all good. Give me some replies. All good, all clear. This question is finished. You can go to next story. All clear, just give some replies. All clear, right? All clear, okay? All clear, right? Okay, all good. Next story. Next story. Next story. Right. So then we'll go to next question. Next question. The next story. Right. We'll go to 2000. We'll go 2000 what? After doing that question. Right. Okay. Right. Next story. Next story. We'll go to. We are doing another micrometer question. 2004 AL question. 2004 AL question. That story. 2004 AL story. Okay. Right. So I'll completely erase the board. Okay. I think we took so much time for the previous question, but we'll quickly finish this story very soon without taking that much of time, because I gave some explanations and I did the question. This story quickly will get the answer. 2000, 2004 level question. 2004 level story. Okay. What they're asking? They're asking name the parts of the micrometer screw gauge labeled as A, B, C, D. A, B, C, D. Right? Now, there's a problem, right? A should be, according to my idea also, A should be sleeve. But in that year, they have mentioned A as the main scale. Right? They have given the answer. They have given correct for main scale. But even I also agree that A must be sleeve. But in the marking scheme, it is mentioned as main scale. Right? A B must be circular scale for sure. I don't know the micrometer. Right? They have given A as the main scale, but we can clearly see that the way they mark the arrow is they are pointing the sleeve, right? It should be sleeve, but in the marking scheme they have given main scale. Capital B is no doubt that this is circular scale. Capital B is circular scale, no doubt, circular scale. Circular scale. And C should be, right, thimble. Thimble. D should be thimble head. Thimble. Capital D should be thimble head. Clear? Thimble head. Thimble head. Right. This story clear. Clear? Simply done. Simple B Roman number 1. Simply done. Simple B Roman number 1. This idea. What they're asking. What is the least count of the above micrometer screw gauge in millimeter? Least count above micrometer screw gauge. To find the least count, I should know the pitch, because least count means, we all know that least count means what? Pitch over number of divisions in the circular scale. Pitch over number of divisions in the circular scale. Just to explain that, remember in micrometers, pitch is always equal to the smallest division in the main scale. When you go to that main scale in the micrometer, you can see that in the main scale, they have marked the main scale in 0.5 millimeter. because you can see the divisions above the index line as well as you can see the divisions below the index line. In that case, main scale is marked in 0.5 millimeter divisions. They have the smallest division in the main scale is 0.5 millimeter. Right? The smallest division in the main scale is always equal to the pitch. Therefore, pitch is how much? 0.5 millimeter. Right? 0.5 millimeter over number of divisions in the circular scale. You can see that means 4505. That means in the circular scale there are only 50 divisions. Simple and must be 50. 50. Then what is your least count? The least count must be how much? Least count must be 0.5 over 15 is how much? 0.01 millimeter. Simple. B, Roman number 2, write down the scale reading. Write down the scale reading for the diameter of the ball shown in the figure 1 in millimeter. They are asking us to write the observed reading in the given figure 1. Figure 1, they have given a micrometer. They are asking us to write the observed reading from that micrometer. Then you want to measure the main scale reading. Then you want to obtain the circular scale reading. That's story. Number 2. Roman number 2 story. I will draw the micrometer story. If I draw it, index line. We can see that 5.56. Look here. This division, right? This division. That is 5. They have marked this division as 5, right? So we can see this division, a division below the index line. Again, we can see a division almost closer to the circular scale H. Always we consider the main scale reading as the division in the main scale closer to the circular scale H. So therefore, your main scale reading must be 6 millimeter. 6 millimeter. 5.5. This division belongs to 6 millimeter. So remember, main scale reading must be, right? Main scale reading must be 6 millimeter. Main scale reading is equal to 6 millimeter. What is the circular scale reading? I explained that circular scale reading is always equal to the division in the circular scale coinciding with the reference line into the least count. What is the division coinciding with the reference line? The division. What is the division? Coincide the reference line 48. It should be 48. This Q must be the division circular scale coincide the reference line is how much? 48. This is 48. This is your Q. Then I can find the answer. Circular scale reading is how much? The division in the circular scale coinciding with the reference line into least count. 48 into 0.01 millimeter. Therefore, 0.48 millimeter is your circular scale reading. But they are asking what is the observed reading of this micrometer. So we know observed reading. Observed reading is equal to what? Main scale reading plus circular scale reading. Therefore, 6 millimeter is main scale reading. 0.48 millimeter is your circular scale reading. Therefore, 6 millimeter plus 0.48 millimeter, it should be 6.48 millimeter. 6.48 millimeter is your observed reading. Right? Observed reading is how much? 6.48 millimeter. Clear ni? Done ni? Done. Next story. Next story. Next they are asking what? Next they are asking the question. Roman number 3. Roman number 3. Right? Roman number 2, write down the scale reading for the diameter of the ball shown in the figure 1 millimeter. That is clear, that is okay. Roman number 3, they are telling that figure 2 shows a situation in which micrometer screw gauge is adjusted to determine the zero error. Now see, in the given diagram also, zero division circular scale is above the reference line. In this given scenario also very clear, zero division circular scale is above the reference line. That means it belongs to positive zero error or negative zero error. It belongs to negative zero error, right? State the correct value for the diameter of the ball in millimeter. Roman number 3, I want to obtain the correct, accurate diameter. I want to obtain the correct measurement. First of all, you want to calculate the zero error. Then, okay, I will explain the story. Roman number 3. Next story, Roman number 3. Next story, Roman number 3. Roman number 3, next story. Roman number 3. Okay, right, see. Okay. Okay. Now, in that given diagram, figure 2, you can see that zero division circular scale is above the reference line. That indicates the error is negative. In case if your zero division in the circular scale is above the reference line, it is showing negative zero error. Right? Then quickly find the division in the circular scale coinciding the reference line. The division circular scale coinciding the reference line is how much? That is how much? That must be, right? The division in the circular scale coinciding the reference line. That is how much? Reply. That must be how much? That must be how much? That must be 47. 47. Right? 47. The division in the circular scale coinciding the reference line is how much? That is 47. 47 is your Q. Then what is the equation to calculate the negative zero error? Negative zero error equation is n minus q into least count. Number of divisions in the circular scale is 50 minus q. What is your q value? 47. 47 into the least count I found. Least count is 0.01 millimeter. Least count 0.01 millimeter. You can find the negative zero error. It's a negative zero error. What is your negative zero error? That is equal to 50 minus 47 is 3 is 0.03 millimeter. 0.03 millimeter. This is the negative zero error. We know that if there is negative zero error, to obtain the correct measurement, to obtain the correct diameter for that ball, we should add the zero error to the observed reading. Therefore, the correct measurement, remember, Roman number 3, they are asking the correct measurement, accurate diameter for the ball. Correct measurement is, we know that, observed reading plus zero error. Observed reading is, I found that 6.48 millimeter. 6.48 millimeter plus zero error, 0.03 millimeter. Okay, done. To structured, time is almost 1 hour finished. Right, now target is discussing another 4 structure say questions. What is the answer? 6.51 millimeter is your answer. Simple, not difficult, simple. Next story. Next story they are asking what next story? Next story they are asking the Roman number 4, write down the fractional error of the measurement. Write down the fractional error of the measurement for the diameter of the ball. Numerical simplification is not necessary. Fractional error means, if you can remember, that is equal to what? Least count over the reading. Least count over the reading is the fractional error, right? Then Roman number 4. Roman number 4, fractional error. Fractional, if fractional error equals, remember, least count over the reading. Least count is 0.01 millimeter, reading is 6.51. You can keep your answer like this, 0.01 0.01 millimeter over 6.51. No point of writing millimeters because they get cancelled out. Fractional error is how much? 0.01 over 6.51. Some people can keep 1 over, if you multiply up and down by 100, 1 over 651. If not, you can keep answering this way also, no issue. Finished. Next idea. Next idea. Roman number 5. What is the precaution taken in the micrometer screw gauge to avoid overpressure the object? The precaution is what? Once the spindle almost reached the object, we stop rotating the spindle using the thimble and we start rotating the spindle using the thimble head. Right? That is the precaution. When the moment spindle just touched the object, we can hear that clicking sound. It ensures that object just touched the spindle, therefore don't rotate anymore. That is the idea. You can write the story there beautifully. Okay, 5 also done. 5 also done. Finished. Right, next story. Next one, C part is not difficult. C part. A wire of circular cross section, length is approximately 55 centimeter and diameter is how much? Diameter is 4 millimeter. Now remember one story, okay? I will tell you one story, very important story. When you consider vernier caliper and micrometer, sometimes in your exam they can ask you that what is the maximum range of a measurement that we can obtain from a micrometer. Remember, for a micrometer, the maximum measurement that you can obtain from a micrometer is 2.5 centimeter, if not 25 millimeter. This story is somewhat important, write on somewhere else. It's an important story. Okay. Generally, okay, there can be some deviations from a micrometer. From micrometer, you can measure 0 to 2.5 centimeter, if not 25 millimeter. Not 25 centimeter, 25 millimeter, 2.5 centimeter, if not 25 millimeter. This is the maximum measurement that you can obtain from a micrometer. Right? In case if you want to measure 5 centimeters, you can't use micrometer. For a vernier caliper, this is varying. For a vernier caliper, you can measure 0 millimeter to 150 millimeter, if not 15 centimeter. This is the standard vernier caliper, but there is another vernier caliper. In that vernier caliper, you can measure maximum 20 centimeter, 200 millimeter. But roughly remember, vernier caliper, the maximum measurement that we can obtain is 150 millimeter. But there is a deviation. Some vernier calipers we can measure till 200 millimeter also. That story put in your mind. This story also important. Right, next story. Next idea. Right. Wire of circular cross section, length 55 centimeter approximately, diameter 4 millimeter, is fixed to a disc, diameter 5 centimeter, right? Thickness 3 millimeter as shown in the figure. Magnitude given in the approximate values. Now Roman number 1, they are asking what? See Roman number 1. See Roman number 1, they are asking what? They are asking what? See Roman number 1. They are asking, of the measuring instruments, meter ruler, spirometer, vernier caliper and micrometer screw gauge, write down the most suitable instrument for the measurement of each of the above quantities. I draw the diagram roughly, right? The diagram roughly. Okay. They have given D2. This is D2. Diameter of this large cylinder. D1, the small diameter. That is your D1. The length is simple L. The length is simple L. Right? Thickness of this plate is, that is simple T. Thickness of the plate is simple T. Plate thickness, this gap is simple T. Right. Now they are asking what is the most suitable measuring instrument to measure L, D1, D2, T. Right? L, D1, D2, simple T. Most suitable measuring instrument, this story. What are the answers? But they have given that length is approximately, they have given length of this rod is approximately 55 centimeters something. Right? And they have mentioned in the question diameter D1. D1 is approximately 4 millimeter. 55 centimeter, this is 4 millimeter approximately. 4 millimeter. D2. D2 is how much? D2 is approximately 5 centimeter. D2 is approximately 5 centimeter. Milli. Thickness approximately 3 millimeter. Thickness approximately 3 millimeter. Okay. Then tell me the suitable measuring instruments. They have given micrometer, vernier caliper, millimeter ruler, spirometer. Right? They have given spirometer, meter ruler, vernier caliper, micrometer. To measure L, D1, D2, T, what are the most suitable measuring instrument? To measure the length, no doubt. Length is 55 centimeter. We can't use vernier caliper or we can't use micrometer or spirometer to measure the length. To measure the length, having 55 centimeter length, the suitable instrument is what? Definitely it must be meter ruler. Meter ruler. Right? Meter ruler. Next one. D1. D1, what is the answer? D1. D1. You can use to measure the D1. D1 is around 4 millimeter. To measure a 4 millimeter measurement, we can use micrometers. Micrometer. Micrometer. D2. D2 means diameter of this plate. That is around 5 centimeter. Right? But remember, micrometer can measure from 0 to 2.5 centimeter. So if you want to measure a measurement having 5 centimeter length, micrometers we can't use vernier caliper. By using the external jaws of the vernier caliper, you can measure D2. Vernier caliper. Vernier caliper. Caliper. Next story. Thickness, simple T. Again, thickness is 3 millimeter range. If you want to measure very small measurements, better if you can use the micrometer. Again, micrometer. Again, micrometer. Simple story. Right? Simple. Roman number 1 also done. Roman number 2. Roman number 2, they are asking what? Roman number 2, they are asking what experimental procedure would you follow to obtain a better value for the thickness of the disc? General story. Right? If you want to obtain an accurate value for the thickness, you should obtain the thickness measurement at 3 different locations in the plate. And then you want to obtain the mean. Right? So you are placing the micrometer at this location, you are obtaining the reading 1, thickness T1. You are placing your micrometer at this region and you are obtaining a measurement thickness T2, thickness T3. At least 3 readings obtained for the thickness and obtain the average, if not mean of those 3 thickness values. Therefore, mean thickness how much? Mean thickness. Right, Roman number 2, you mentioned at 3 different locations, obtain the thickness using the micrometer. Then get the mean value of that. That's what you write down here. That's what you should write down here. Roman number 2. Roman number 2. Okay ni? Roman number 2 story. Okay ni? That story. Last one. Simple D. The thickness. Simple D. The last one. The thickness of a certain type of polythene sheet is much smaller than the least count of a micrometer screw gauge. Propose a method to estimate the thickness of a sheet using micrometer screw gauge. This story explained in the theory classes also explained. This story explained in the theory classes also. Right? Simple D, they are asking what simple D they are asking. Now they are telling a story like this. Simple D. Simple D. The thickness of a certain type of polythene sheet is much smaller than the least count of a micrometer screw gauge. Right? When you consider a polythene sheet, its thickness that is smaller than the least count of micrometer. What is the micrometer least count? 0.01 millimeter. Right? If the thickness of one polythene sheet is less than the least count of a micrometer, 0.0 millimeter, can we measure the thickness of one sheet using the micrometer? Because this micrometer can measure the minimum measurement is 0.01 millimeter, but the thickness of the polythene is further smaller than the least measurement. They ask in such cases, how are you going to measure thickness of one sheet? We know practically, sir, thickness of one sheet is less than 0.0 millimeter. Micrometer can measure a minimum measurement is 0.0 millimeter. If the thickness of the polythene sheet is less than that, actually micrometer can't measure that measurement. But still they are asking, how are you going to measure the thickness of that sheet? Then you want to say an answer like this. You should select n number of polythene sheets rather than using one single sheet. Identical simple n number of sheets, right? If you use, right? But remember, you should choose simple number of sheets. Once you use simple number of sheets, overall thickness. Now there are simple number of sheets. We don't know exactly how much. You have a count. You should select simple number of sheets. The total thickness of simple number of sheets should exceed the least count of your micrometer. Now you can measure the thickness of this entire sheet bundle. Now you can measure the thickness of this entire sheet bundle. After obtaining the thickness of entire sheet bundle, divide it by number of sheets in the bundle. That will give the thickness of one sheet. That is the idea. Right? And then we finished the two structure says from micrometer. Then we'll talk about spirometer ideas. Right? Then we'll talk about Wernicke caliper ideas. Right? Till now, all clear. Just give some replies. All clear. Everything is good. All good. Put some replies in the chat. All clear. All clear. Put some replies in the chat. Put some replies in your chat if all clear. Put some replies. Put some replies. All clear. Put some replies. Put some replies. All good. Put some replies. Okay, nicely simple story. Simple story. If you properly learn everything, very simple story. Time is 9:15. We started the class at 8 o'clock. We are taking the break around 9:15. We'll do the class till 9:45. We'll take a break. Again, we are continuing. Next story. All good ni? Nice ni? Simple story. Simple story. Really simple story. Next idea. We'll go to the question number. Next story. Question number. Right? 9:15. Okay, next story. Now we'll do the remaining stories also. Wernicke caliper idea. Wernicke calipers. Some Wernicke caliper ideas. Okay. We discussed 2024. 2004 is finished. Okay. We'll start doing 2014 A-level paper. If you have the, I think the paper I shared in the group, sometimes you are not able to see it clearly. In that case, I don't know whether you all have the partial books with you. In case if you're not able to see the question clearly, right? You can download some PDF in the website also, right? 2004 level vernier caliper idea, vernier caliper idea, vernier caliper idea. This story, 2004 level story, vernier caliper, past paper, structure is a question. Vernier caliper. We discussed two structures from micrometers. I think you understood the overall idea. We'll talk about vernier calipers. Vernier caliper. Vernier caliper idea. So we are taking a break around 9:45, sometimes 10 o'clock. We'll take a break around 9:45, if not 10 o'clock, right? Vernier caliper. So we'll quickly finish this story. Next story. Next idea, right? What they're asking, what they're saying. They're saying a story, simple. The following measuring instruments are given to determine the density of a material. Density of a material of a small uniform cylindrical container. Density of a material of small uniform cylindrical container of the form shown in the figure. It seemed like a hollow cylinder, right? We have done similar questions in our target papers also. Big exam 2 also, we have done similar questions. Now they have given a hollow cylinder, all right? And they have given two measuring instruments to obtain the measurements. Number one is vernier caliper. Number two is electronic balance. Normally, electronic balance they provide to measure a mass. Vernier caliper we are using to measure diameter, internal diameter, external diameter. Sometimes we can use the vernier caliper to measure the depth of an object, height of an object. So we can measure all the measurements from vernier caliper: depth, diameter, external, internal, height, depth, everything we can measure using a vernier caliper, right? Simply, before using a vernier caliper for taking measurements, what is the first step that you should take? Not only vernier calipers, when you are using vernier calipers, micrometers, pyrometers, what is your first step? You should check whether there is a zero error or not. If it is vernier caliper story, you should bring your external jaws. You should bring the external jaws of the vernier caliper, just touch each other and you should obtain the zero error. Whether there is zero error or not, you should check that. Right? First one, simply before using a vernier caliper for taking measurements, what is the first step that you should take? Bring the external jaws in contact with each other and check whether vernier caliper has a zero error or not. If there is a zero error, find the zero error with a sign. Simply story. Can write down. Simple B. What they ask? Simple B. Simple B is asking that write down an expression for the density of material of the container in terms of volume of the material V and its mass capital M. Right? Write down an expression for the densities D of material of the container in terms of volume of the material capital V and its mass capital M. If you know the mass of an object and volume, density equation, all will story. Density means what? Mass or volume. Density means we all know that. Density means the equation. You must remember this equation. Density equals, remember, mass or volume. In your A levels, they don't provide equations. Standard equation they don't provide. You must learn by heart. Density means what? Mass or volume. Simple C story. Simple C. Simple C. Next is simple C. Simple C. In addition to the two measurements, the outer diameter and inner diameter of the container state the other measurements you would take using the vernier caliper to determine the volume of the material. Right. Okay. Okay. Volume of the material. Right. Look here. This story. This story. Okay. I know the given diagram. It's a hollow cylinder. It's a hollow cylinder. The given diagram is a hollow cylinder. I want to measure the volume of the hollow cylinder. Very carefully listen. Okay, right. Okay, right, the story. Okay, righty. Next story. Okay, right. Okay, right. Now my target is I want to measure the volume of this hollow cylinder. Now they're asking, other than external diameter and internal diameter, what are the other measurements that you should obtain to obtain the volume of the cylinder? Definitely, to find the volume of this hollow cylinder, you should obtain external diameter. Surely. And you want to obtain the internal diameter also. Right? Then, now they ask in the question, other than external diameter, internal diameter, what are the other measurements that you obtain to find the volume of the cylinder? Then definitely the height of the cylinder. I just mark it as h1 something, the height h1 something. I want to know, I should measure the height. Then what? The depth of the cylinder, this gap. h2, if not d2, whatever depth, h2. Okay. So then you want to know that height, then depth, h1, h2, you want to know. Internal diameter, external diameter, you want to know that. But they have given three spaces. Why they have given three space? Because we don't know that with the that vernier caliper has a zero error or not. So therefore, we should know the zero error of the vernier caliper also. Therefore, that question answer must be. This question answer must be what? Answer must be, in addition to the two measurements, the outer diameter and the inner diameter of the container, state the other measurements that you would take using the vernier caliper to determine the volume of the material is what? First, you should know the zero error. So you want to calculate zero error. Then depth and height of the cylinder. That story. Simple D, the figure Roman number 1 to 5 below show all the relevant positions of the main and the vernier scale pertaining to one set of measurements that has been taken in order to determine the volume of the material of the container. Relevant jaws, depth, rod, etc. that have been used to take the each measurement are shown on the right hand side of the figure. Height of the container is greatest than its outer diameter. Okay, right. Identify the figures correctly and relate them to the measurements that have been indicated in C and fill the table given below. Story. I think diagrams are not clear. Now, if I do the diagrams for your understanding, right? Look here. Okay. Look here. This story. I will explain. Don't worry. This is somewhat important story, right? Okay. Look here. A story. This idea. This idea. Right. Now, in the Roman number 1 figure, you can see that external jaws are touching each other. When what is the reading that we obtain when external jaws are touching each other? What is the type of reading that we obtain by touching the external jaws together? The zero error. So that Roman number 1, that figure belongs to calculate a zero error. Right? If I do the main scale and vernier scale for your understanding, main scale and vernier scale. Right? Figure 1 is we are calculating the zero error. Okay? Right. Now in that question, main scale is marked in millimeters. main scale is marked in millimeters. 0, 1 millimeter, 2, 3, 4, 5 millimeter. Likewise, main scale marked in millimeters. Okay, main scale. The vernier scale, vernier scale. So we should find the division coinciding with the. First of all, we should know whether we should find the zero error. We want to calculate whether it's a positive zero error or negative zero error. If you can remember the theory, we learned that theory we learned that. If you can remember, this is the zero division in the main scale. I explained that if the zero division in the vernier scale is right side from the zero division in the main scale, if the zero division in the vernier scale is right side from the zero division in the main scale, the error is positive zero error. The error is positive zero error. Positive zero error. Equation to find the positive zero error is how much? The division coinciding with the, if you can remember the equation. Let's say if Q division, how to find the positive zero error? This is your main scale, vernier scale. When the zero division in the vernier scale is right side from the zero division in the main scale, then we know it's a positive zero error. To calculate the positive zero error, what is the equation? The division in the vernier scale coinciding with one of the main scale division. The division in the vernier scale coinciding with one of the main scale division into the least count. Let's say Q division in the vernier scale is coinciding with the one of the main scale division. Then the zero error equation we can remember that is equal to what? That is equal to Q into least count. Q into least count. The story we know, we learned. This story we learned. In case if the vernier caliper has negative zero error, I explained that. How do we identify vernier caliper as a negative zero error? If the zero division in the vernier scale is left side from the zero division in the main scale. Right? Zero division in the vernier scale is left side from the zero division in the main scale. Right? Main scale, vernier scale. Then how to calculate the negative zero error? Negative zero error, if you want to calculate it, negative zero error you want to calculate n minus Q into least count. What is n? Number of division in the vernier scale. N means what? Number of division in the vernier scale. What is Q? The division in the vernier scale coinciding with one of the main scale division. Right? This story we know. How to calculate positive negative zero errors in a vernier caliper. Vernier caliper idea. Right? Okay. And now we'll go to this story. Roman number 1, we can identify that external jaws are touching each other. By touching external jaws together, what type of measurement that we are obtaining? We are obtaining the what? Zero error only. Right? Then that right side diagram is given. Why they have given external jaws touching each other? We want to understand from the diagram that measurement belongs to zero error measurement. Okay, that story. Now, if I exactly mark the divisions properly, now, okay, right, properly, okay. If I mark divisions properly, I think you can't see it clearly, right? I will tell you the idea. In Roman number 1, okay, in Roman number 1, right, in Roman number 1, if you're carefully, I think you can't see it clearly, I will draw the diagram in the board. Actually, zero division in the vernier scale is in that diagram. In that diagram, zero division in the vernier scale is right side from the zero division of the main scale. Then that is, we all know that that is positive zero error. Vernier scale zero division is right side from the main scale zero division. Therefore, it's a positive zero error. And exactly second division in the vernier scale is coinciding with one of the main scale division. Exactly second division in the vernier scale is coinciding with one of the main scale division. Right, then how do we calculate the measurement zero error? First reading is belongs to zero error. Therefore, the zero error is how much? Zero error. That is how much? That must be how much? Q into the least count. Q is 2. 2 into least count is, we know. Least count, how do we calculate least count? In that given vernier caliper, I should know the least count. How can I find the least count? How can I find the least count? That story. That story. Okay. Okay. How can we calculate the least count? Right? How many divisions in the vernier scale? There are 1, 2, 3. There are 10 divisions in the vernier scale. There are 10 divisions in the vernier scale. Okay. How many divisions are there? There are 10 divisions. There are 10 divisions. Okay. Right. 10 divisions. Okay. When you check the number of divisions in the vernier scale, there are 10 divisions. Simple N is 10. Just calculate. In the vernier scale, there are 10 divisions. Simple N is 10. What is the main scale division? Main scale is divided into 1 millimeters. 1 millimeter, 2 millimeter, 3 millimeter. Right? Main scale division is 1 millimeter. Number of division the vernier scale is 10. Then you can remember, for a vernier caliper, what is the equation to find the least count? For a vernier caliper, least count equation is, remember, main scale division over number of divisions in the vernier scale. Simple in. If you can remember, least count equals what? Main scale division over number of divisions in the vernier scale. Then main scale division is how much? 1 millimeter. So least count is equal to what? 1 millimeter over number of divisions in the vernier scale is 10. 1 over 10. 1 over 10. That means how much? 0.1 millimeter is the least count. Least count is how much? 0.1 millimeter. Then actually I was calculating zero error. Right, I realized zero division of the vernier scale is right side from the zero division of the main scale. That means this error belongs to positive zero error. Right, then I can check the division in the vernier scale coinciding with one of the main scale division. That is what? That is 2. Then I can find the zero error, positive zero error. I can find that Q into least count. Q into least count. What's my Q? 2. Least count is 0.1 millimeter. My answer is what? Zero error is how much? That is equal to how much? 0.2 millimeters is my zero error. Now they have given a table and we should complete that given table. Now they have given a table. We should complete that given table. If I do the table quickly, right? If I do that given table quickly, given table, reading of vernier caliper, current reading. Okay, name of the measurement. Right. If I do that given table quickly, look here. This table. Figure row number 1, 2, 3, 4, 5. Reading of vernier caliper. Reading of vernier caliper. Okay. Corrected reading, name of the measurement. Figure. This one is figure. Row number 1. Reading of the vernier caliper. Reading of vernier caliper. That is how much? That is in millimeters, 0.2 millimeter, right? So in Roman number 1, reading of the vernier caliper is 0.2 millimeter. 0.2 millimeter. 0.2 millimeter, right? Name of the measurement is zero error. Zero error. Zero error. It is actually a positive zero error. Zero error. If you want further, you can mention positive zero error. Positive zero error. If you want to mention positive zero error, right? Roman number 1 diagram is okay. Roman number 2. Roman number 2 story, they have given that second diagram. If I do the second diagram, now they have given nearby that main scale and vernier scale, right side, they have given the external two jaws. Right? We can see in that diagram of the vernier caliper, external jaws are extended. That means basically, by using those external jaws, they are measuring a kind of external diameter. They are measuring a kind of external diameter. That's why external jaws are extended. If not, we don't want to extend the external jaws, right? Okay. Then second figure belongs to measurement of external diameter, second story. Roman number 2 story. Roman number 2 story. If I do that diagram roughly, for your understanding, Roman number 2 story, right, that story, okay, right, see, if I draw it for your understanding, we can take a break at 10 o'clock, 10 o'clock we'll take a break, the main scale, the main scale, main scale, zero division is somewhere here, right? Okay, main scale they have given the 2 millimeter. Okay, in the main scale you can see this 2 millimeter, sorry, 2 centimeter. This division in the main scale is 2 centimeter. 2 centimeter, right? This division belongs to 2 centimeter. And when you check the zero division in the vernier scale, that is exactly right side to the 2 centimeter division in the main scale. Zero division, very careful listen, zero division in the vernier scale is exactly right side from the 2 centimeter main scale division. Right? Vernier scale zero division is right side from the 2 centimeter division. Then what is your main scale reading? Your main scale reading must be 20 millimeter, if not 2 centimeter. Right? I explained how to find the main scale readings in vernier calipers. You should select the main scale division which is closer to the zero division in the vernier scale and which is right left side from the main scale division closer and left side to the zero division in the vernier scale must be your main scale reading. I will say once again, the division closer and left side to the zero division in the vernier scale is your main scale division. Right? Okay. Then when you check the division in the vernier scale coinciding with one of the main scale division, that is 2. Okay, that is 2. Just check with that. If you have a proper diagram, just check with that. That is 2. That is 2. That is 2. Right? The division in the vernier scale, that is exactly coinciding with one of the main scale division. That is 2. Okay. Then how to find the external now measurement? What is the reading of this story? Main scale reading is 2 centimeter, if not 20 millimeter. Right? The reading is how much? The reading is how much? Observed reading is how much? Observed reading is main scale reading is 2 centimeter, if not 20 millimeter. If you convert to millimeters, 20 millimeter plus vernier scale reading. What is your vernier scale reading? The division in the vernier scale coinciding with the main scale is 2. 2 into the least count. Least count is how much? That is 0.1 millimeter. 0.1 millimeter. Therefore, your observed reading is how much? Observed reading is how much? That is 20.2 millimeter. Right? 20.2 millimeter. 20.2 millimeters. Right? The Roman number 2 reading of the vernier caliper is how much? The observed reading. This belongs to observed reading. Okay? This belongs to observed reading. That is how much? 20.2 millimeter. 20.2 millimeter. 20.2 millimeter. Now this column says what? This is the observed reading. Okay? Second column belongs to observed reading. The reading that you observe, obtaining. Third column belongs to correct reading. Third column belongs to correct reading. The correct reading is how much? Correct measurement. This vernier caliper has a positive 0 error. In that case, in order to obtain the correct measurement, we should subtract the 0 error from the observed reading. For a positive 0 error, remember, for a positive 0 error, we should subtract the 0 error from the observed reading. Right? Then, observed reading is 20.2 millimeter. 0 error is 0.2 millimeter. If you subtract 20.2 minus 0.2, remember, positive 0 error means, positive 0 error means to obtain the correct measurement, 0 error must be subtracted from the observed reading. Roman number 2, observed reading is what? 20.2 millimeter. If you want to obtain the correct measurement, correct external diameter, right? 20.2 minus 0.2 millimeter. That is how much? That is exactly 20.0 millimeter. This is external diameter. Measuring the external diameter. External diameter. Diameter. Right? 10 o'clock we'll take a break. Okay. Next one. Roman number 3. Third story. Roman number 3 figure. Roman number 3 story. They have used the internal jaws. That means basically they are measuring the internal diameter. They are measuring the internal diameter. Roman number 3. They are using the internal jaws, means they are measuring internal diameter. Okay. If I check that measurement, Roman number 3. Roman number 3 story, if I draw here. Roman number 3 story, if I draw here. Roman number 3. Roman number 3. Learn, okay, we'll take a break at 10 p.m. Till now, focus. Learn something for every question. Don't waste your time. Time is very important. The time that you are spending, you have value for that. That's a very important thing. That's a very important thing. Right? Even you never learned vernier caliper stories also, I'm explaining some important theories together and I'm explaining the question. I am not getting the answer quickly. Right? I want to revise the theory soon. Right? Okay. Can't waste the time. You have the exams also mostly tomorrow. Right, next story. Somehow we'll finish 6 practicals and we'll decide what to be done. Right, next story, internal diameter story. If I draw that diagram, you can see that. You can see Roman number 3. You can see. Okay. You can see like this. You can see Roman number 3. This is 1 centimeter mark. This mark belongs to 1 centimeter. That is 10 millimeter. This mark belongs to 1 centimeter. That means 10 millimeter. Then 11, 12, 13, 14, right? 15. You can see 15 is only 16. 16. This division is 16 millimeter. This division 16 millimeter. You can see your 0 division in the vernier scale is nearby this 16 division. Okay. Your vernier scale 0 division is where? Nearby the 16 millimeter main scale division. Right? Okay. The next story is the division in the vernier scale coinciding with the main scale division is, if you check carefully, the division in the vernier scale coinciding with one of the main scale division is in the given diagram. that is exactly again 2. Second division only coinciding with the main scale division. Again, that is 2. Right? Then how do we obtain the observed reading? Observed reading. We all know that observed reading means what? Main scale reading. How do we find the main scale reading? The division in the main scale. Okay? The division in the main scale closer and left side from the 0 division in the vernier scale is your main scale reading. Right? The division closer and left side from the 0 division of the vernier scale is your main scale reading. That is how much? 11 millimeter, 12, 13, 14, 15, 16 millimeter. 16 millimeter plus vernier scale reading is what? Q into LC. Vernier scale reading is what? Q into LC. The division in the vernier scale coinciding with the main scale is 2. Least count is how much? 0.1. Other answer is going to be how much? 16.2 millimeter. 16 millimeter plus 0.2 millimeter. 16.2 millimeter is your answer. Observe reading. Roman number 3 answer is what? 16.2. 16.2 millimeter is your observed reading. Right? Again, if you want to obtain the correct internal diameter, since it's a positive 0 error, you should subtract the 0 error from the observed reading. 16.2 minus 0.2. Again, 16 millimeter. This belongs to internal diameter. Diameter. Roman number 4 and 5, then finish. Roman number 4, 5. Right, see? Really time consuming story. If you haven't learned properly, it's really time consuming story. Roman number 4. Fourth one story. Roman number 4 diagram, if I draw here. Right? Fourth one. This division in the main scale belongs to 3 centimeter. Vernier scale 0 division is exactly here. So what is the main scale division closer to the 0 division in the vernier scale? 3 centimeter mark. So your main scale reading is how much? Main scale reading is 3 centimeter. The division in the vernier scale coinciding with the main scale is what? It's second division. Second division in the vernier scale is coinciding with one of the main scale division. Right? In that case, what is your observed reading? In this case, observed reading is how much? Main scale reading is 3 centimeter. If you convert to millimeters, 30 millimeter main scale reading plus vernier scale reading is how much? Q into LC. The division in the vernier scale coinciding the main scale division is 2 into least count is 0.1. So 30.2 millimeter is your how much? Observed reading. Right? Observed reading is how much? 30.2 millimeter. Then the correct measurement must be subtract the 0 error, then 30 millimeter is your exact measurement. But this measurement belongs to what actually? Roman number 4, you can see they have used the rod. Vernier caliper, the rod. Why we are using a rod in the vernier caliper? To measure the depth. So this belongs to the depth. This belongs to the depth, to measure the depth of the hollow cylinder. Depth. The last one. The last one is what? The last one is it's a large distance. The last one measurement is very large. So main scale reading is how much? If you check carefully, the last one story, if I draw here, if I draw the diagram here, the last one. Always find the division in the main scale always find the division in the main scale left side and closer to the 0 division in the vernier scale. Always find the division in the main scale left side and closer to the 0 division of the vernier scale. What is that division? That division is what? That division is, if you carefully check that one, you can see 35 millimeter. The main scale division is 35 millimeter. Then find the division, the vernier scale coinciding with the main scale division. Again, that is, if you check that one, that is going to be 4th division, right? The division in the vernier scale coinciding with the main scale division is what? 4. Now you can calculate the observed reading is what? Observed reading is what? Main scale reading is 35 millimeter plus vernier scale reading. The division in the vernier scale coinciding with the main scale division is 4 into least count 0.1 millimeter. Final answer is how much? 35.4 millimeter is your answer. 35.4 millimeter is your answer, right? 35.4 millimeter is your answer. The correct measurement is how much? 35.2. Subtract 35.4 minus 0.2. 35.2 millimeter is your answer. That is belongs to the height. Total height. Really nice question. Really nice question. This question covers all the idea regarding vernier caliper. Right? Covering all the idea regarding vernier caliper. Story done. Simple. Simple. This is they have taken as x1, x2, x3, x4. See? This measurement belongs to x1. This measurement is x2, x3, x4. Then what they are asking? 10 o'clock, it's time to take a break. Then they are saying the question, right, the last part. Simply, Roman number 1, write down an expression for the volume of the material of the container in terms of the symbols x1, x2, x3, x4 given in the below table. x1 is external diameter. x1 is external diameter. x2 means what? Internal diameter. x2 is internal diameter. What is x3? x3 is depth. x3 is what? That is the depth. What is your x4? That is your height. How do we find this hollow volume? Before finding the hollow volume, first of all find the external volume. Then find the internal volume. When you find the external volume, right? I erase the stories. Very simple story. When you find the external volume, external diameter is x1. Just now we learned that equation to find the, if you know the external diameter. Today only we learned that. If you know the external diameter of a circular cross section, if you know the external diameter of a circular cross section, how to find the cross sectional area? Cross sectional area means we all know that pi d square over 4. Just explained. Pi d square over 4. If you want to find the cylindrical volume, let's say you know the cross sectional area of a cylinder, and if you know the height of the cylinder, what is the equation to find the volume of a cylinder? If you know the cross sectional area, if you know the height, simple h, the equation to find the volume of the cylinder is what? Volume equals what? Volume equals cross sectional area into the height. Okay, all your maths. Now let's say now you know the diameter of the cylinder. Diameter of the cylinder, you know that, simple d. Then we can write down cross sectional area of the cylinder as what? Pi d squared over 4. If you know the diameter of a cross sectional area, then it is pi d squared over 4. Then instead of writing capital A, I can write down pi d squared over 4. Then we can write down volume of cylinder is equal to what? Exactly. Cross sectional area is what? Pi d squared over 4. Height is simple h. This is the equation to find the volume of a cylinder. Now what's my target? My target is to find the external, internal, total cylindrical volume, hollow cylindrical volume. Okay. Just think that. Forget about this internal story. Just think there's a cylinder having an external diameter x1, its height is x4. There's a cylinder, its diameter is x1, its height is x4. How do you find the volume of the cylinder? This big one. Forget about the small cylinder inside, forget about that. Only think about that external big cylinder. If you want to find the volume of the cylinder, what is the equation? That is V1, big cylinder volume. Big cylinder volume VB. Big cylinder volume VB, pi. Diameter of the big cylinder is how much? X1. D means what? X1 squared. Over 4. What is the height of the big cylinder? X4. X4. Then pi x1 squared into x4 over 4 is the volume of that big cylinder. And now forget about the big cylinder. Only think about the small cylinder. Small cylinder having a diameter x1 and height x3. When you find the volume of the small cylinder, what is the equation? Pi, diameter of the small cylinder is what? X1. Sorry, x2. Diameter of the small cylinder is how much? X2. X2. X2 squared over 4. X2 squared over 4. What is the height of the small cylinder? X3. X3. Now you want to understand, we obtain this hollow cylinder by cutting that small cylinder from that big cylinder. When you remove that small cylinder from the big cylinder only, you are getting that given hollow cylinder. Then what is the equation to find the hollow cylinder volume? Reduce the small cylinder volume from the big cylinder volume. If you reduce the small cylinder volume from the big cylinder volume, that is going to be the hollow cylinder volume. Right? Simple. Therefore, remember, hollow cylinder volume is, hollow cylinder volume is, that is how much? That is big cylinder volume minus small cylinder volume. That means pi x1 squared x4 over 4 minus small cylinder volume is pi x2 squared into x3 over 4. Then simple, pi over 4 common factor out. X1 squared x4 minus x2 squared x3. This story. Hollow cylinder volume. Done. Done. Last one. Last story, Roman number 2. Roman number 2. Somewhat complex idea, but you can learn something from this question. That's the important thing. Roman number 2. Time is 10 o'clock. We will do this question and we'll finish and we'll take a break. Okay. Roman number 2, using the expression written under simply Roman number 1 above and readings that have given in the above table simple D, calculate the volume. Now won't substitute the volumes. Won't substitute the values. Right, we'll substitute the values. Now simple E Roman number 2. Simple E Roman number 2. Hollow cylinder volume is how much? Pi over 4. Pi is how much? Pi means how much? Pi means they asked us to consider pi as 3. Pi is 3. 3 over 4. 3 over 4 bracket. X1 is how much? X1 is 20 millimeter. I don't convert into meters. I get the answer in terms of millimeter cube. X1 is how much? X1 is 20 millimeter. 20 squared into X4. X4 value is how much? 35.2. X4 means 35.2. Right, minus X2 value is how much? X2 is 16. X2 means 16 millimeter squared into X3. X3 value is how much? 30. So when you simplify this, you will get an answer. If you simplify this, you will get an answer. That answer is how much? If you simplify this, you will get an answer. That answer is how much? If you simplify it, you are getting an answer. That answer will be. If you simplify it, you are getting an answer. This answer will be right. 480 something. Right, 480 something. We can do the simplification here and we can get the answer. Right? The answer must be okay. Simplify it. When you simplify it, can simplify, take some time. Simplify it. So you are getting an answer in millimeter cube. Volume now. If you substitute in millimeters, you are getting the answer in millimeter cubes. Simplify and get the answer. That answer is how much? That answer. Simplify it and get the answer. Simplify it and get the answer. 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 Okay. If I simplify it, let's say now simplification. Simplification 3 over 4 into 10 o'clock. It's time to take a break also. 20 scale is how much? 20 scale is 400. Okay. 400 into 35.2 minus 16 scale is how much? 256 into 30 something. Likewise, when you simplify it, you are getting an answer. Right? So just put that answer. So you get the answer, this volume in millimeter cube. Okay? And then the last one is they are asking the density. The last question they are asking what? They are asking the last part, according to the reading of the electronic balance, if the mass of the container is 9.6 grams, find the density of the material of the container, give your answer in kilogram per meter cube. Right? Remember the density means we know that mass over volume. Mass given in how much? Mass given how much? Mass given in, right? Mass is 9.6 grams. How do you convert 9.6 grams into kilograms? Multiply by 10 to the minus 3. If you want to convert grams into kilograms, multiply by 10 to the minus 3. Volume is how much? Volume of the cylinder is how much? This volume. Right? This volume we obtain in millimeter cube. Right? Put this value here. Convert that millimeter cube into meter cube. How do you convert millimeter cube into meter cube? Remember, if you want to convert millimeter cube into meter cube, remember you want to multiply by 10 to the power minus 9. If you want to convert millimeter cube into meter cube, remember you want to multiply by 10 to the minus 9. Okay? Then you will get the answer in kilogram per meter cube. The story. It's time consuming. If not, I will do simplification. Right, 10.5. This practical also finished. We completed 2 micrometer practicals, 1 bigger vertical practical, 3 more practicals are pending. That story. Put a small reply, all good, all clear answer. We'll take a break now. Put a small reply, all clear, all good answer. Put a small reply. All clear, all good. Put a small reply. Put a small reply. All clear, all good. Put a small reply. Put a small reply. Put a small reply. All clear, all good answer. All good ne? Right, okay. All good ne? Nice ne? Simple, right, okay. Okay ne? So time is 10:05. We'll take a 20-minute break and come ne? 20 minutes enough ne? 20-minute time is 10:05. Come at 10:25. Take a break and come at 10:25. Come at 10:25. Take a break and come at 10:25. All right. So then we'll talk about we have 3 pending stochastic questions. One more question from vernier caliper. Right? One more question from vernier caliper, next story. Time is 10:24. We'll try to stop the class by 11:30 maximum. But our plan is somehow we'll complete 3 more stochastic questions. Vernier caliper 1 and spirometers 2 practicals. Right? So then you go to the past paper 2000. We discussed 2024 we have done. 2004-14 we finished. 2002 A-level question. 2002 A-level question. We'll start 2002 A-level question. 2002. Right. Right, okay. Uh, 2002 A-level stochastic question also. Vernier caliper question. 2002 A-level. Again, vernier caliper question. Vernier caliper question. Right. What they're asking? In that question, they're asking first story. Figure shows a part of the main scale and vernier scale of a certain vernier caliper when their respective 0 marks coincide. So we all know that in a vernier caliper, when 0 division of main scale and 0 division of vernier scale are coinciding, there is no 0 error, right? That means your caliper is really accurate, right? Okay, right? What is the length? Simply number 1, what is the length of a vernier division in millimeter? What is the length of a vernier division in millimeter? Now you can clearly see that now they considered 19 millimeter from main scale and they divide into 20 divisions. Look here, this story. This story. If you're careful see the story, right. Now this part is somewhat important. Stay focused. Look here. Right. 0 division in the main scale and 0 division in the vernier scale, they are coinciding. Okay. Now likewise, there are divisions. There are divisions in the main scale. Okay. There are divisions in the main scale. In this scenario, they considered 19 division, 19 millimeters, right? 0 millimeter, 1 millimeter, 2 millimeter, 3 millimeter, likewise. If you carefully check the diagram, they considered 19 millimeter, right? This belongs to 2 centimeter. This division belongs to 2 centimeter, right? This division in the main scale belongs to 2 centimeter. They considered 19 divisions in the main scale. One division is 1 millimeter. If they consider 19 divisions in the main scale, what is the total length from 0 to 90 division? 19 millimeter. Remember, this is this division. Okay. This division is 90 division in the main scale. Then what is the length from 0 division to the 90 division in the main scale? That length is exactly 19 millimeter. Very simple logic. In the main scale, that is divided in millimeters, 0, 1 millimeter, 2 millimeter, they consider 19 divisions. What must be the length from 0 division to the 90 division the main scale? 90 millimeter. So they have taken 19 millimeter length. They divide into 20 segments in vernier scale. How many divisions are in the main vernier scale? There are 20 divisions, right? Number of divisions the vernier scale is how much? It's 20. Okay. So when you consider 19 millimeter length, and if you divide it by 20 divisions, what must be the length of one vernier division? What must be the length of one vernier division? Simple. 19 millimeter length is divided into 20 divisions of the vernier scale. What must be the length, the gap between two adjacent divisions? The gap between two adjacent divisions must be how much? 19 millimeter over 20. Right? Remember, vernier scale division is how much? 19 millimeter we divided into 20, divided by 20. Then, when you consider adjacent to vernier divisions, that gap is how much? That gap is 0.95 millimeter. You understand? Now they are asking in that part, in the question number simple Roman number 1, what is the length of a vernier division in millimeter? Right? Simple logic. In the main scale, they consider 19 millimeters, right? 19 millimeter length, they divided into 20 divisions in the vernier scale. Then the length of one division in the vernier scale must be 19 over 20. That is 0.95 millimeter. If not, you want to understand this vernier scale division means the distance between two adjacent vernier divisions. That is 0.95 millimeter. That story. They can ask the story in your exams. They will be very careful this idea. Next one. Roman number 2, hence or otherwise determine the least count of the instrument. Generally, the most of the time we are using least count as what? Main scale division over number of vernier scale divisions. If you can remember, mostly there are two equations to find the least count. The first equation is, remember, right? Simple Roman number 1, simple Roman number 2. Simple A Roman number 1. Vernier scale division is how much? 0.95 millimeter. There are two equations to find the least count. The first equation, the very popular equation, mostly we are using that. Least count means what? Main scale division over number of divisions in the vernier scale. Least count is equal to what? MSD over number of divisions in the vernier scale. Now very clear now, main scale divisions are in millimeters. 1 millimeter, 2 millimeter, 3 millimeter. So main scale divisions are in 1 millimeter. So your MSD is how much? 1 millimeter. Number of divisions in the vernier scale, there are 20 divisions. So therefore 1 over 20 is going to be your least count. So least count of this vernier caliper is how much? 1 over 20 means 0.05 millimeter. This is the popular equation for the least count. Least count equals MSD over simple in. Main scale division over number of divisions in the vernier scale. But remember, there is another equation also. I explained in theory classes. The second equation, remember, the second equation is, remember, least count means main scale division minus vernier scale division. Least count equals main scale division minus vernier scale division. This story also you want to remember. This story. Then least count equals main scale division. Main scale divisions are in 1 millimeter, 2 millimeter, 3 millimeter. Main scale divisions are in millimeter, 1 millimeter. Minus, what is the vernier scale division? Length of one vernier scale division is how much? 0.95 millimeter. 0.95 millimeter. So then you are getting the least count as what? Same as 0.05. 1 minus 0.95 is how much? That is exactly 0.05 millimeter. So there are two equations to find the least count. Remember, now many can remember this story. This equation many can remember. Because mostly we are using this equation to get the least count. But many forget this equation. Don't forget this equation. Don't forget this equation. That's already done. Next idea. Next idea. Next idea. Then Roman number 3. According to the above figure, what is the least distance in millimeters? According to the above figure, what is the least distance in millimeter of the vernier scale that has to be moved in order to make a vernier scale mark coincide once again with the main scale mark? What is the answer? If you want to again coincide vernier scale division with one of the main scale division, you should move it by a distance equal to least count. Very simple. Now very clearly. Now currently they clearly mentioned in the beginning, 0 division in the vernier scale is exactly coinciding with 0 division in the main scale. They're asking again how much distance you want to move the vernier scale in order to coincide vernier scale division with one of the main scale division. You should move the vernier scale by a distance equal to least count. That is the important theory. Short note story also, in your short note point book also mention that story. Right? So you should move the vernier scale by a distance equal to the least count. Then only again, first division in the vernier scale will coincide with one of the division in the main scale. That's very important. Roman number 3, it's a strange, nice section. Nice story. Roman number 3, nice idea. Put in a short note point book also. Roman number 3. That idea explained. The next idea. Next one. Next they're asking what? Next they're asking simple B part. Cylindrical metal piece has a cylindrical hole as shown in the figure. We have done a very similar question. In order to determine accurate values of the following measurements, which part of the vernier caliper out of external jaws, internal jaws and depth bar would you use? That is simple. Simple B, Roman number 1, 2, 3, 4 is easy. Right? Simple B, Roman number 1, 2, 3, 4. Simple B, that part is easy. Roman number 1, Roman number 2, Roman number 3, Roman number 4. Answers. D1, H1, D2, H2. D1, H1, D2, H2. To measure D1, you want to use what? External jaws. External jaws. External jaws. To measure H1, H1 is what? The depth. Sorry, H1 is what? H1 is, right, D1 is external jaws. Then H1 is what? H1 is the height. H1 is the height. To measure the height, again you want to use what? External jaws. To measure the height, use external jaws. D2 means the depth. To measure the depth, so D2 means the internal diameter. D2 means internal diameter. Then use your internal jaws. IG, internal jaws. H2 is the depth. Therefore, use the depth rod. Depth rod story. Simple. Simple C part. Right. Simple C, they are saying same story. Simple C, they are saying write down an expression for the volume of the metal in terms of D1, H1, D2, H2. Right. This idea explained the previous question also. Remember the hollow volume. Simple C, the hollow volume equals to what? External volume. Hollow volume equals how much? That is equal to external volume minus internal volume. Right? How do we find the external volume? Pi d squared over 4 into h. Volume means pi d squared over 4 into h. Learn by that equation. External volume means what? Pi. External diameter. That is d1. Pi d1 squared over 4. What is the height? That is h1. Minus internal volume. Pi. Internal volume is d2. Internal diameter is d2 squared over 4. The depth is how much? Depth is h2. Is your answer. Simple. Simple D, the last part finished. Simple D, the last part finished. It's not a big question. Simple D. Simple D, Roman number 1, they are saying that. Simple Roman number, they are saying that when simple T2 was measured using the vernier caliper mentioned above, D2 means what? D2 means internal diameter. When D2 was measured using the vernier caliper mentioned above, the portion of the vernier scale obtained relative to the main scale is shown below. what is the value of D2? You want to obtain the reading. Easy, ni? Easy. The reading is how much? If I mark that. Main scale, vernier scale. Simple D Roman number 1. Simple D Roman number 1. Main scale. Main scale, vernier scale. Here is the zero division of the vernier scale. The closest and the division closer and left side of the vernier scale zero division is what? How much? In the main scale. The main scale division closer and left side of the vernier scale zero division is what? That is how much? That is 10, 15, 16. 16. Right? 16. The main scale division closer and left side to the vernier scale division is what? 16 millimeter. So main scale reading is how much? 16 millimeter. Then find the division of the vernier scale coinciding with one of the main scale division. Then find the vernier scale division coinciding with one of the main scale division. What is that one? That one must be how much? That one must be, if you check carefully, that one must be 50. Right? 50. That one must be, right? What is the vernier scale division? Very simple. What is the vernier scale division coinciding with one of the main scale division? That is exactly how much? That is exactly 10, 11, 12, 13. 13 division. Simple. 30 division in the vernier scale is coinciding with one of the main scale division. 30 division. Then we can obtain the observed reading is how much? Observed reading equals main scale reading is 16 millimeter plus vernier scale reading is how much? The division in the vernier scale coinciding with one of the main scale division is 13 into the least count. Did you find the least count? 0.05. Least count is 0.05 millimeter. What is the answer then? Answer must be 16 millimeter plus 13 into 0.65 means how much? 13 into 5 is 65. 0.65 millimeter. Answer going to be 16.65 millimeter. 16.65 millimeter is your answer. Observe reading. Done. Simple. The last part. The last one is last one, then 41, last one. What is the fractional error of D2 measurement? Simple. Fractional error means we all know the fractional error means what? The least count over the reading. Least count over the reading. Least count is 0.05. So fractional error means, remember, fractional error means least count over the reading. Least count is 0.05 millimeter over reading is 16.65. Is your fractional error. Simple. Then 4 structures finished. Now 2 structured from spirometer story. So I will do 1 structured from past paper question from spirometer and 1 model paper question from spirometer. That story. The last story, then 2 micrometer stories finished, 2 vernier caliper stories finished, spirometer idea. Spirometer idea. Spirometer idea. Spirometer idea. Right? Learn something for every question. Right? Sometimes when you are doing these questions, you don't get the tiny small stories. Right? Every question, learn something. Right? Get an exposure from every question. Sometimes they seem like very simple. Right? Rather than doing the question, when you just read it, you feel like, yeah, very simple story. Yeah, I learned external jaws, internal jaws, least count. But when you start doing the question, you will realize that no, when I read it, I feel like easy. But when I'm doing the question, it's very difficult. The things I felt like easy, when I'm doing the question, now I'm feeling like I can't remember what to be done. Therefore, always do the question and confirm whether it's easy or difficult. Never read. Some people, what they do, the biggest mistake they do is, if they have a marking scheme, especially past paper questions, if they have a marking scheme, what they are doing, they are reading the question and they are referring the marking scheme. No, basically they are reading the question as well as marking scheme. Then they feel like, yeah, this question, external jaws, yeah, this is the answer, yes, very easy, yeah. But if they do the question, they will realize they can't even find the least count. right? Okay, last two stories. 10:45, last stories. Okay, spirometer question, passive question. Spirometer passive question. That is 2000. Then last question, 2011 A level question, right? Okay, spirometer theory. I think nicely I explained the theory classes, right? Okay, I properly explained the ideas when you're measuring the depth, when you're measuring the height, especially when you're measuring the radius of curvature. What should you do? I explained in the classes properly, nicely. Okay, this idea. 2011 A-level passive essay questions, spirometer idea. 10:45, I think by 11:30 we will be able to complete the paper stories, right? 2011 question. Idea. Spirometer. 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 Structural essay questions. Alright. Okay. Simple. Simple. Now read the question. Now they say what? Spirometer story. Not difficult. Spirometer, they say that figure shows a spirometer used in a laboratory. Number of divisions in the circular scale is 50. Number of divisions in the circular scale is 50. Linear progress made by circular scale on the vertical scale in 2 complete rotations as 1 millimeter. Linear progress made by the circular scale on the vertical scale in 2 complete rotation is 1 millimeter. What I understood is spirometer basically what includes a screw with a circular plate. Okay, spirometer idea. Okay, listen. Basically, spirometer consists one screw, 3 legs, one main scale, a circular scale. Circular scale is engraved on a circular plate. When the circular plate rotates, you want to understand screw also rotates because circular plate is connected to the screw. Okay, this is the idea. Simple story. Right? Okay, look here. Right. This is, you can, I don't know the legs of the spirometer. Right? I don't know the legs of the spirometer. This is the circular scale. Circular divisions are marked on the circular scale. Right? If you can remember the story, when the screw, if not the circular plate is rotated by one rotation, when the screw, if not circular plate is rotated by one rotation, the distance traveled by the tip of the screw is equal to what? Pitch. Once again, I'm saying that when the screw, if not circular plate, rotated by one rotation, distance traveled by the screw tip is equal to the pitch. I explained that generally the pitch is always equal to the smallest division in the main scale. Okay? Generally, the pitch is always equal to the smallest division in the main scale. Now they mentioned, very simple story, they mentioned when you rotate the screw by 2 rotations, when the screw is rotated by 2 rotations, the distance traveled by the screw tip is how much? 1 millimeter. That is what they're saying. They're saying the linear progress made by the circular scale on the vertical scale in 2 complete rotation is 1 millimeter. Basically, they're explaining that when the screw is rotated by 2 rotations, 2 turns, the distance traveled by the tip of the screw is how much? 1 millimeter. Then, can you please find the pitch? Pitch is what? When the screw is rotated by 1 rotation, the distance traveled by the screw tip is we call as pitch. Then what is the pitch? 2 rotations, distance traveled by is 1 millimeter. 1 rotation, distance traveled by must be how much? 0.5 millimeter. Therefore, remember the pitch must be equal to what? 0.5 millimeter. The pitch is equal to 0.5 millimeter, right? The pitch is 0.5 millimeter. You can remember that, you can remember spirometers. How do we find the least count? I explained that least count can be found by least count equals pitch over number of divisions in the circular plate. If you can remember spirometers, spirometer least count is what? That is equal to pitch over number of divisions in the circular plate. And I explained that this pitch is always equal to the smallest division in the main scale. Sometimes main scale is marked in 1 millimeter divisions. Very rarely, some spirometers, main scale is marked in 0.5 millimeter divisions. Right? This story, remember. Okay. What they are asking? Then they are telling some stories. Okay. Spirometer is used to determine the radius of curvature of the curved surface of a plane or concave lens. Such determination, spirometer is placed on the curved surface of the lens as shown in the figure 2, right? Okay. Next one is what? After obtaining the measurements H and B, which are shown figure, okay, radius of curvature, okay, right, okay. Simply, what is the least count of the spirometer? Simply, least count means, remember, pitch over number of divisions in circular plate. Pitch over number of divisions in your circular plate. They clearly mentioned the circular plate divisions are 50. Given data, they have given number of divisions in the circular plate is how much? 50. Simple is 50. Then simple A, they are asking us to find the least counting. Least count equals how much? The equation. Least count is pitch over simple length. Very simple. Least count equals pitch over simple length. Pitch is now we know 0.5 millimeter. Pitch is 0.5 millimeter. Number of divisions in the circular plate is how much? That is 50. Therefore, least count is how much? Therefore, least count is 0.01 millimeter. Okay? Right, simple. Simple A done, simple B part. Simple B, before placing the spirometer on the curved surface, it has to be adjusted by placing it on flat glass plate. How do you experimentally make sure that the tip of the screw just touches the glass plate? I explained that before obtaining readings from the spirometer, first of all, you should check whether there's a zero error in the spirometer or not. Right? Like when you are using the micrometer and vernier calipers, before obtaining the measurements from those instruments, you should check first whether they have a zero error or not. In spirometers also, before obtaining the measurements, you should check whether spirometer has a zero error or not. How do you check whether spirometer has zero error or not? First of all, you should bring the tips of legs and the screw tip in the same horizontal plane, right? Now we can assume that tips of the legs are in the same horizontal plane, so screw is moving up and down. So therefore, you want to bring the screw tip in the same horizontal plane where tips of the legs exist. How do you ensure screw tip is also in the same plane where other legs tips exist? Look here. Look here. This story. I told you that first you want to find zero error. How to find zero error? You should bring the screw tip and tips of the legs. You want to bring screw tip and tips of the leg in the same horizontal plane. By looking the image of the screw through the glass, right? Is your screw. Right? Once you place the spirometer on the glass flat surface, we can see the image of the screw through the glass surface. Right? When the moment the screw tip and its image tip exactly coinciding, just touching, then only we can say that screw tip exactly reached what? So when the moment screw tip is exactly coinciding with the image of the screw tip, then only we can tell that screw tip and other leg tips are in the same plane. Right? Okay. That's what they are asking. They are asking that before placing the spirometer on the curved surface, it has to be adjusted by placing it on flat glass plate. How do you experimentally make sure that the tip of the screw just touches the glass plate? Then you want to say that you want to write like this. You want to write down like this. You want to write down. We want to bring all the tips of the legs and tip of the screw in same horizontal plane to ensure the tip is all the tips in same horizontal plane. We are looking the image of the screw. We are looking what? So we are ensuring the tip of the screw and its image tip are exactly touching each other. When the moment that happens, we can ensure that all the tips are in the same horizontal plane. That is story. That's story. Okay, simple C part. Then the spirometer is placed on the curved surface of the lens. What is the adjustment would you make before taking the next measurement in order to determine H? Right, then the spirometer is placed on the curved surface of the lens. What is the adjustment would you make before taking the next measurement in order to determine H? Okay. Right. Okay. The story. Simple A story done. Simple B part also explained. Simple B part explained. Simple C part. Simple C part. Simple C part. Simple C part. Okay. Simple C part. Now your target is what? You want to measure the radius of curvature of concave lens. But in theory classes we learned how to find the radius of curvature for a convex lens. Look here. If I do the concave lens, you want to find the radius of curvature of this concave lens. Okay. The given diagram. Okay. Right. Okay. Right. Okay. Right. Now, first step is we should find the zero error. When you have found a zero error, I told you that we want to bring all the tips in the same horizontal plane. Right, then you want to calculate the zero error. Right? You want to check whether there is zero error. If there is zero error, you want to find the zero error. Okay. Now, immediately after you found zero error, when you place the spirometer on this concave lens, so we all know that only these three leg tips touching the curved surface. But screw tip does not touch the curved surface. If you want to touch the screw tip, on the curved surface, you should rotate the screw downwards. If now, when you place the spirometer on this concave lens, the tips of the legs touching the curved surface. But screw tip is not touching the curved surface. If you want to touch the screw tip on the curved surface, you should rotate the screw and you want to move the screw downwards till screw tip just touches the curved surface. Right? You want to move the screw downwards. Okay? That is what you want to write down there. What adjustment would you make before taking the next measurement in order to determine H? Right, by rotating the screw, we are bringing screw downwards till the screw tip just touches the concave lens, concave plate, whatever. Simple, say Roman number 1 idea, okay. Then, now initially we know that, now your fine is simple side, your fine is gap, this gap on H. Why? Before tip was at the same horizontal level where tips of the legs exist. Before screw tip and tips of the legs are in the same plane, but now screw tip is somewhere here. Okay, right, see this idea. Before screw tip is somewhere here at this level. Now screw tip is at this level. Screw tip has moved from this level to this level. That is basically your spirometer reading is equal to this height. I told you, always spirometer measures the gap between the circular two plates. Spirometer always measures the before and after circular plate positions. If not, spirometer always measures the gap between before and after screw tip location. Spirometer always measures the gap between before and after screw tip positions. Before screw tip was at this level, now screw tip is this level. So spirometer measures the reading, simple as gap. That idea, right? Roman number 2, what is the reading that you would take for the spirometer after above mentioned adjustment? What is the reading that you would take from the spirometer after above mentioned adjustment? Right? Right? Okay. So you can write down main scale reading and circular scale reading. If not, I told you there's a method, right? You can write two answers. Now the reading that you're obtaining is once the screw tip just touches the concave lens, then you want to obtain the main scale reading and the circular scale reading. If not, what you can do, there are two methods. Second method, if you can remember, without using the main scale, I told you that by using only the circular plate, you can obtain measurement. In that case, number of rotations you turned upwards, number of rotations you turned downwards. Likewise, the answer is, if you mention only the answer, main scale reading and circular scale reading, that is enough. Right? Roman number 2 mentioned that main scale reading and circular scale reading. Roman number 2 only mentioned that main scale reading, circular scale reading. That story. Simple D. Simple D. Simple D idea. After extensive use, the reading taken from the vertical scale may not be so accurate in some spirometers. What is the reason for this? I told you, right? When you use the spirometer for long time, right, there will be a play between, right, spirometer screw and the nut, right? In that case, what will happen? In that case, I taught you that circular plate will be inclined because of that, right? So when if you're taking the accurate readings, I told you that if this is your main scale, your circular plate must be horizontal, right? But with that worn out story, now what will happen? Your circular plate is inclined like this. As a result, you are obtaining a false reading in the main scale, right? That story you want to mention there. Okay? That story you want to mention there. Right. Simple D. Simple D part. Okay? Then simple E part. In order to determine capital R, you need to measure the mean distance between the spirometer legs. I told you that equation. That equation R equals what? R equals B squared over 6 simple H plus H over 2. This equation, what is your B? When we were deriving this equation, we marked this B as simple A. What is simple A? Distance between two adjacent legs, right? Now, simple E, they are asking, in order to determine capital R, you need to measure the mean distance between the spirometer legs. Simple B. You want to find simple B, right? Okay. Roman number 1, what measuring instrument would you use to determine simple B? There are two methods. You can use meter ruler, then the method is different. If not, you can use the vernier caliper also. It's a different method. There are two methods to measure the simple B. You can measure meter ruler and you can find the B. If not, you can use vernier caliper and you can find B, right? What measuring instrument would you use to determine B? You can use meter ruler, if not vernier caliper. Roman number 2, what experimental steps would you follow in order to determine simple B? In case if you're using the meter ruler, first of all, you want to place the spirometer on a half sheet and you want to press the spirometer on the half sheet tightly in order to mark the locations of the leg tips on the sheet, right? You should hold spirometer on the white sheet tightly. Then when you remove the spirometer, you can see the marks of the spirometer leg tips. Then you want to mark them and you should draw a triangle. I told you that spirometer leg tips are forming a kind of equilateral triangle. Then after drawing that equilateral triangle, you can measure the length of one side. Right? Once you after you mark the tip portions of the legs, if you complete the triangle, if you measure this length by using a meter ruler, that is going to be the length between spirometer legs. Simple A for simple B. Simple B. Simple B. Right? Ni? Simple B. Simple B. Right? Okay? Ni? What experimental steps would you use to follow in order to determine simple B? Simple F, give another use of spirometer except the measurement of radius of curvature. We can use spirometers to measure height, thickness stories. Right? Height, thickness stories. Suggest a method to further decrease the least count of the spirometer given above. That is important theory. Huh? Important theory. There are two ways. We know least count is what? Least count equals pitch over number of divisions in the circular plate. If you want to reduce the least count further, there are two options. If you are planning to reduce the least count further, option 1 is you can reduce the pitch. Let's say for an example, now pitch is 0.5 millimeter. If you can reduce the pitch to 0.1 millimeter, you can reduce the least count further. First option is reduce the pitch. Second option is increase the number of divisions in your circular plate. When you increase, rather than marking 50 divisions in your circular plate, if you mark 100 divisions, then what will happen? Number of divisions in your circular plate, if you increase, the least count will further decrease. Option 1 is reduce the pitch. Option number 2, increase the number of divisions in your circular plate. That story also clear. Really simple story, finished. Right? Just put a reply. Now we discuss 5 structured essay questions quickly as soon as possible. 5 structured essay questions finished. We'll discuss one more model paper question. Just put some replies. All okay, all clear. Just put a small reply. All clear, all good. Put a small reply. All clear, all good. Put a small reply. Put a small reply. 11.6. Put a small reply. Put a small reply. All okay, all good. Put a small reply. Put a small reply. All okay, all good. Put some replies. All okay, all good. Okay, nice, simple story. Right, okay. Last story. Last story. I will share a paper. Okay, I'll share a paper. Okay, I'll share in the group. Right, okay, I'll share a paper in the group. Right, where is that paper? I'll share a paper in the group. Give me a second. 11.5, 11.10. Okay. Right. Okay. Okay. If I share that paper in the group, look here. I'll share the paper here. Okay. Then story okay. Okay. I shared the paper in the group. Refer it. The last story. Last say question. Then today plan is okay. Right. If I share the paper in the group, okay. Last story. So give me a small feedback also, okay? After class finishes, with everything is okay, effectively you spent, right? Is it worth enough to join for today's session? Give me a small feedback also, right? That story. Last one. Last one, speedometer question. Give two occasions where speedometer is used. FWC paper question. FWC paper question. FWC paper question. Right, first story. The last question, 6 marks is a question. FWC paper question. FWC. Simply. Simply, they are asking what? They are saying give two occasion where speedometer is used to find the thickness or depth, if not to find the radius of curvature. Right? Ni? Roman number 2. Simply, Roman number 1 done. Roman number 2. When a speedometer circular scale complete two rotation. When speedometer circular scale complete two rotation, it moves 1 millimeter distance on the main scale. Number of divisions in the circular scale is 50. Find the least count of the speedometer. Simple ni. Simple ni. Simple ni. Simply Roman number 1 clear. Roman number 2. When you rotate the circular plate in front of the screw by two rotations, the distance traveled by the screw tip is 1 millimeter. That is what they mentioned there. Okay? That is what they mentioned there. Okay? When a speedometer circular scale complete two rotation, it move 1 millimeter distance. On the main scale, number of divisions of the circular scale is 50. Find the least count. First of all, now we know the equation. For a speedometer, least count is what? Pitch over number of divisions in the circular plate. For a speedometer, least count equation is pitch over number of divisions in the circular plate. I know now, clearly they have given number of divisions. The circular plate is almost 50. If I can find the pitch, I can find the least count LC. To find the pitch only, they have given this data. For the two rotations, distance traveled is 1 millimeter. Remember, always pitch means if you rotate the screw or circular plate by one rotation, distance traveled by the screw is the pitch. When you rotate the screw or circular plate by one rotation, distance traveled by the screw tip is we call as pitch. Then for two rotations, distance traveled is 1 millimeter. For one rotation, distance traveled by the screw is how much? 0.5 millimeter. That is going to be your pitch. That is your pitch. This is your pitch. Then I can find the least count easily. The least count is how much? LC is how much? Least count equals pitch over N. Pitch is how much? 0.5 millimeter over simple is what? 50. Again, least count is how much? 0.01 millimeter. Least count is how much? 0.01 millimeter. This story. Simple. Next, what they are asking? Next, what they are asking? Next one, they are asking that simple B. Now, the above speedometer is placed on a glass plate. Above speedometer is placed on a glass plate and its four legs were adjusted until they touched the glass plate. At that instant, above diagram shows. Find the reading. We know that when the all four tips in the same flat plane, that reading belongs to zero error. That reading belongs to zero error. Okay? Now see, now we learned there are two types of zero error. I told you don't learn like positive or negative story. Speedometers, we don't talk positive or negative zero errors for a speedometer. Right? Now very clear, when the tips are in the same horizontal plane, that belongs to zero error. There are two types of zero error, I taught you. First zero error is when the circular plate is above the zero division in the main scale. The second type of zero error is when the circular plate is below the zero division in the main scale. Okay? Now this is very clear. Look here. Look at the circular plate. The circular plate is below the zero division in the main scale. If I know the diagram for your understanding, This zero error belongs to circular plate is below the zero division in the main scale. The story. Here is your zero division in the main scale. But where is your circular plate? Circular plate is exactly below the zero division in the main scale. Circular plate. Right? 0.5, below 0.5. Right? Below 0.5. Look here. Below 0.5. Zero division, this is 0.5 millimeter, I think. 0.5 millimeter. This is 1 millimeter, I think. This is 1 millimeter. This reading is 0.5 millimeter. It's important. This reading is 0.5 millimeter. Main scale reading is 0.5 millimeter. This main scale reading is 0.5 millimeter. That is important. Where is your circular plate? Circular plate is below zero division in the main scale. It is exactly between 0.5 millimeter and 1 millimeter. The circular plate is exactly between 0.5 millimeter and 1 millimeter. What is the division in the circular plate coinciding with the main scale? They have given division in the circular plate coinciding with the main scale is how much? 42. The division in the circular plate coinciding with the main scale is how much? 42. 42. If I do the top view, not important, right? Top view, okay? Main scale, circular scale. The division circular scale coinciding the main scale is how much? Is 42. And now you can find the zero error easily. You can find the zero error easily. What is the answer? What is the answer? They are asking what? They are asking what? They are asking, right? They are asking above spirometer is placed on a glass plate and its four legs. Its four legs were adjusted until they touched the glass plate. At the instance above diagram shown, find the reading. You have the reading, right? Then see, I told you one story. Right? If you can remember the theories, we learned that there are two types of zero error. Okay, when the plate is above zero division, it's a one type of zero error. When the circular plate is below the zero division, that is another type of zero error. If the plate is below the zero division, the equation to find the zero error, I told you that Q in least count. Right? Zero error equation, if you can remember, sorry, N minus Q. If the plate is below the zero division, the main scale, the equation of the zero error is how much? N minus Q in least count. Least count. Right? Very simple story. When the plate is below the zero division in the main scale, zero error equals what? N minus Q least count. But in here, you want to consider this main scale story also. That is the only different story from what we learned to yesterday classes. Now here very clear, what is your main scale reading now? You want to calculate the zero error. We know that this plate is moving downwards. This plate is moving downwards. Plate is between 0.5 millimeter to 1 millimeter. Right now, above also divisions are there. Right now, 0, 0.5 millimeter, 1, 1.5, likewise. Right? Main scale divisions are prepared. This plate is between 0.5 millimeter to 1 millimeter between. This plate is between 0.5 millimeter and 1 millimeter. Then what must be your main scale reading? It must be 0.5 millimeter. And how do you find the circular, if not circular scale reading? This story. So remember, if you want to calculate the zero error, if that reading is how much? The zero error reading is how much? The zero error reading is how much? That is equal to, you want to add this 0.5 millimeter. Normally, Our normal scenarios, remember normal scenarios, they provide the main scale division in millimeters. So normally our plate is in between 0 and 1. In that case, there we don't read any main scale reading. Do you understand? Normally we only consider circular scale reading, and that is what we take as 0 error. But in this question, what happened was main scale is divided into 0.5 mm divisions. And our plate is between 0.5 millimeter and 1 millimeter. Therefore, we want to consider our main scale reading as 0.5, and then you want to add this story. Number of divisions in the circular plate is 50 minus the division in the circular plate coinciding the main scale is 42 into the least count. Least count is 0.01. 0.01 millimeter. Then your answer is how much? Then your answer is 0.5. Yeah, 8 ni. 50 minus 42 is 8 ni. 0.08. Therefore, you are getting that 0.58 millimeter as your zero error. Zero error. The different part is this part. Adding this main scale division, main scale reading, adding is somewhat different story that you learned when yesterday. If you compare with yesterday's stories, when we are calculating zero error, we are adding a main scale reading. Because why? Our plate is between 0.5 and 1 millimeter. Then the main scale reading is what? 0.5. That story is somewhat new story for you. Roman number 2. Again the spirometer was not finished. Okay, within 10 minutes we'll stop the class. Again the spirometer was placed on a convex glass and its length were adjusted until they touched the curved surface. The following diagram show the instance. Find the reading. Now reading. Now story. Roman number 2. Roman number 2 now story. Roman number 2 now story. Look here. Roman number 2 now story. Now story. Roman number 2 now reading. This reading belongs to zero error. This reading is the observed reading. Main scale. The main scale. Main scale. Where is our circular plate? Circular plate is exactly above the zero division. Circular plate is exactly above the zero division. Circular plate is exactly between 1.5 millimeter and 2 millimeter. Circular plate is exactly between 1.5 2 millimeter. Circular plate is exactly between 1.5 and 2 millimeter. This is 2 millimeter. Is 1.5. So the main scale reading is what? Is it 2 or 1.5 now? This is 1.5 millimeter. 1.5 millimeter this one. Our plate is, circular plate is exactly at this location. Circular plate is between 1.5 millimeter and 2 millimeter. Then what is our main scale reading? Right? When the plate is going upwards, means 0, 1.5, 2. Then plate is going upwards. When the plate is still has not yet reached the 2 millimeter border. Then the main scale reading is how much? 1.5 millimeter. Main scale reading is 1.5 millimeter. What is the division of the circular plate coinciding with the main scale? That is how much? That is how much? That is last 10 minutes. So that is how much? 29. 29 division. 29 division is coinciding with the main scale. Then what is your reading? I told you that when the circular plate is above the zero division, if you can remember, when the circular plate is above the zero division, circular scale reading equals what? Q into least count. When the circular plate is above zero division, circular scale reading is how much? Q into least count. The division coincides the main scale into the least count. Now easy. Now easy. And now the reading is how much? Observed reading. Observed reading is how much? That is equal to main scale reading is 1.5 millimeter. Main scale reading is 1.5 millimeter plus circular scale reading is how much? Circular scale reading 29 into least count is how much? LC 0.01. LC is how much? 0.01. This is your observed reading. Observed reading is how much? 1.5, 0.29. How much? What is the answer? 1.79, 0.29, 0.1.5, 0.29, 1.7 millimeter, 1.79 millimeter. Observed reading is 1.7 millimeter. That story. Okay, next idea. Almost finished. Next story. The next story. Learn. If they ask question, this is what they can ask. They can't ask anything beyond this. Right? They can't ask anything beyond this. Find the height of the center leg raised. They are asking now what is the accurate measurement, correct measurement. Roman number 3, what is the correct measurement? I told you in that case, always check before and after circle plate location. Right? I told you because it's really confusing. In spirometer stories, if here is your zero division in the main scale, before, when you were finding the zero error, the plate was below the zero division in the main scale. Plate was below. So when you are finding the observed reading, actually plate is above the zero division in the main scale. Plate is above. Before reading is, let's take it as R1. This observed reading is your R2. Right? That means this gap is your R1. Before reading is R1, that is zero error. That is your zero error. This gap is zero error. Right? R2 means what? Observed reading. Here to here, this gap is observed reading. Then I told you that always the measurement from the spirometer means the gap between before and after plate location. All spirometer measurement is equal to the gap between before and after spirometer plate location. Before and after plate location. So remember the measurement, that simple H height is what? This gap is simple height. Therefore, if you want to obtain the actual measurement, actual height, correct measurement, remember, correct measurement is what? Observed reading plus zero error. Remember, correct measurement is what? Correct measurement is what? Remember, correct measurement is what? Correct measurement equals observed reading plus zero error. What is observed reading? Observed reading is what? That is how much? That is 1.79. 1.79 millimeter plus zero error, 0.58 millimeter. What is the answer? 1.79, 0.58. What is the answer? 17, 8, 13, 2.37 millimeter is your correct measurement. 2.37 millimeter is your correct measurement. 2.37. 2.37. 2.37. Right. Roman number 4. To determine the radius of the curvature of the glass surface, the distance between the legs should be measured. How do you measure the distance? Two methods are there. You can use the meter ruler. If not, you can use the vernier caliper. That theory we learned, right? If you use the meter ruler, how to get it? That story previous question also explained. If you use the vernier caliper, I told you that. I told you using the external jaws, measure the external length between the legs. At least obtain 3 external length measurements, obtain the mean. Then again using the internal jaws, measure the internal gap between the legs. At least obtain 3 internal readings, get the average. Then that external length plus internal length, average is our answer. That's what we learned. Problem number 5. In the above measurement, distance between the leg is 3 cm. Find the radius of curvature. R equals A squared over 6h, h over 2. Simple. Now they have given R equals what? A squared over 6h plus h over 2. H over 2. A means that distance between the legs. A means distance between the legs. That is how much? 3 cm. 3 cm. If you go to millimeters, 30 millimeter, 30 squared. 6 into h, 2.37 millimeter. 2.37 millimeter plus 2.37 millimeter over 2. You are getting the radius of curvature in millimeters. Simple. Simple. Next story. In spirometer, write down a possible error occur after long term used. Because of wearing out, wear and tear, right, what will happen? The circular plate will incline, then the measurement obtained from the main scale becomes wrong. When circular plate inclines, the measurement obtained from the main scale will be wrong. How can you minimize the error during the measurement? We can avoid main scale reading. We can take the reading only from the circular plate. I told you how to obtain this only using the circular plate. I taught you how to obtain the right readings by neglecting the main scale measurement. Only use the circular plate measurements. How to obtain the reading story I taught you, right? Problem number 3 suggests two idea to minimize the least count of a spirometer. Reducing means reducing the pitch, if not increasing the simple length, number of circular divisions. That's it, right? Okay. So then 6 stories. We have done 6 task essay questions. I think we took around 3 hours. More than 2. I think we took a break, 20-minute break we have taken, right? Okay. Anyways, okay. You may have exam, some of you, right? Get the maximum from every session. That's what I can tell. I think today's session very effective for all of you. Right, students, you are writing the exams. Wish you all the best. Now, what you write? Don't worry, we have a long time to work. Right, when we are working, we can correct our mistakes and we can do. Right, I give a small support possible in my end. Right, learn something from these stories and go to tomorrow exam and write your best. Okay, even your marks is 1 no 100 doesn't matter. Right, we have the time. We can work together more. We'll put the sessions like this. Right, somehow we'll go for A for sure. Our target is getting A only, nothing else. Right? I am teaching to get A. We can go for A because most of you have the potential. Right? Okay. Right? Session is very effective. I think so. Put a small feedback if you like. If not, no issue. Fine. Okay. Right. Then we'll stop the class for today. Then tomorrow exam. After you finish writing the exam, once you come to the home, put a small reply. How was the exam? Exam paper? Send me your exam paper. Right? Right, tell me how was the exam? Is good to bad to anything I taught from these stories came or not in our big exam papers, big exam 1, 2, 3. Just tell me, okay? Right. Then study well. Then we'll stop the session today. Then have a nice day. Have fun.